Um, Distinguished participants, expert speakers, colleagues from our partner organizations, ladies and gentlemen, good afternoon or good morning across different time zones from where you are joining this workshop. On behalf of the Secretariat of the Capacity Development Program on Air Quality Management and Emission Reduction of PM 2.5 for Asian countries, I would like to welcome you to the day 5 session of the workshop on module 5 on air pollution mitigation policies. Thank you for joining this session. I hope you all are doing well and staying safe. I will be moderating the day 5 session on module 5 on air quality management workshop on air pollution mitigation module. Sorry, air pollution mitigation policies module. I would like to inform you, we have already uploaded the PPTs of yesterday's module 4 on air pollution impact assessment on the website. Please visit the website and download the PPTs if you need them. We will upload the video recording of, we have already uploaded basically the video recording of module 4 on YouTube and provided a link on the resources materials section of the website near to the respective module. Today there will be 5 presentations in this module, and all presentations is likely to end at 5:30 p.m. Bangkok Standard Time. So today will be a little longer session, and we hope you will enjoy and learn about air pollution mitigation policies in Asia. However, before we start the presentations, as usual, may I request all the participants to mute your microphone and switch off your video to avoid any disturbance in the streaming of the workshop proceedings. Thank you for your cooperation. Also, may I request the speakers to finish your presentations within 40 to 50 minutes so that the participants will have 10 to 15 minutes for Q&A. Last two presentations are of 45 minutes. So may I request the presentators of last two presentation to finish your presentation within 30 to 35 minutes so that the participants will have some time to ask the questions. As usual, participants are requested to type your questions in the Q&A box. The speakers will answer your questions. I will convey the questions to a speaker to answer. And if you want to ask more questions to a speaker, and if the time does not permit, please send your questions to me by email. I will request the speaker to reply you later. The first presentation of the air pollution mitigation policies, module 5, is perspective on air pollution mitigation strategies and actions in Asia. This presentation is by Ms. Gilinda Batrina from the Clean Air Asia, Manila, Philippines. Ms. Gilinda Batrina is a Deputy Executive Director of the Clean Air Asia. She is a lawyer with 20 years of experience in policy development on clean air, sustainable transport, and climate change mitigation. She helped in drafting the 999 Philippine Clean Air Act, implementation rules and regulation, and led the Asia Clean Fuels and Vehicle programs, which resulted in clean fuels and vehicle policies and roadmap for Vietnam and Philippines. Ms. Gilinda holds a Master's in Environmental Management degree from the Ateneo de Manila University and and University of San Francisco, and a Bachelor of Law from the University of Philippines. Ms. Galinda, the floor is yours. Thank you so much.
Thank you so much, Dr. Verma, and thank you to the organizers of this very relevant and very important training on air quality management. I'll just share my screen now, and Dr. Verma, yes, I think you can see my screen now.
Yeah, we can see
So
your screen.
today, thank you. Today I'm going to speak on my perspectives on air pollution mitigation strategies and actions in Asia, pulling largely from the experience of my organization, Clean Air Asia. For those of you who may have just heard about Clean Air Asia today, we are a 20-year-old non-government organization that has been working in the region for the purpose of improving air quality in Asian cities. And we do so by focusing on three pillars of our work, which are providing science-based policy guidance, ensuring capacity building opportunities are available to national, city, government, and other stakeholders, and informing for action. And we do this through two key programs, air quality and climate change, and sustainable transport. Now, the basis for my 40-minute presentation today will largely be on this document, which I hope you have had a chance to browse. So this is the guidance framework for better air quality in Asian cities. And this set of guidance documents, so we now have 7 of them. These are all outputs from a very long process of consultations with the ministries of environment in the region. It is a product of the joint cooperation of UNEP, Clean Air Asia, and the Integrated Program for Better Air Quality in Asia. So for this particular presentation, I will focus on Guidance Framework 5, which is on clean air action plans. So you might say, what is the relationship between clean air action plans and mitigation actions? So if we take a step back, clean air action plans is where one key component of a clean air action plan is really the mitigation measures that a city or a country commits to undertake to attain an air quality objective. So I just added this photo here of the newest guidance framework document, which is on financing air quality management, because we launched this and made it available on September 7th, the International Day of Clean Air for Blue Skies. So the guidance framework documents are really the foundation of all the capacity building work that my organization, Clean Air Asia, and several others are undertaking. And please do visit this our learning portal, and the materials and the portal itself, including the solutions toolkit, are available on this website. So moving on to the link between clean air action planning and adopting mitigation measures. So I quote here a statement from the Guidance Framework 5, which says that the key features of a clean air action plan include instruments and strategies to comply with air quality standards and emission standards, adoption and implementation of control measures, continuous improvement after compliance, and anticipation of future trends such as national policies and international commitments. So as you can see, the first part really states that a clean air action plan begins with an air quality goal or an air quality objective which in many cases, cities and countries equate with their national ambient air quality standards or their emission standards. And to achieve these objectives, there is a need to adopt mitigation measures to reduce emissions and to ultimately lower the ambient concentration of air pollutants in the air. But the Clean Air Action Plan is not a static document. It is a document that continues, that is alive and needs continuous improvement. For what reasons? Because the situation in our cities change. For example, our cities are growing in terms of population, in terms of economic activity, and therefore our goals may have to be adjusted and mitigation measures will have to be assessed and updated. And we also need, when we are developing a clean air action plan, we have to be looking forward. Usually, a clean air action plan is set for 5, 10, 15 years. Therefore, in our planning, we have to forecast what are the future trends that we think or we foresee may occur in the city. How large will the city grow in terms of population, and what is the impact in terms of energy resources needed, or mobility, the trips that may need to increase towards that future date. And as we know, national policies change over time, and we also have new international commitments we have to meet. So Clean Air Asia's experience in action planning, in helping, in assisting national governments in action planning for clean air spans several decades. And these are some of the work we are doing together with city governments and national governments, which are in different stages of action planning. And we all base the action planning work on this framework for air quality management that is documented in the guidance framework. So this figure here is actually quite simple. So as you can see, the middle circle represents the knowledge base that a city or a country needs in order to develop a science-based action plan. So the starting points are knowing the level of pollution, knowing the sources of pollution through an emissions inventory, and estimating the impact. So having a health exposure assessment will help us know what is our starting point. And with that knowledge, we can then now craft what solutions are feasible for us to attain a specific air quality objective. So these solutions are could be at the national level, need to align with national policies and frameworks. And at the local level, this is where we develop a clean air action plan that houses the measures which mitigate air pollution and greenhouse gas emissions. And of course, um, there is an individual and community level actions which are also important in achieving our air quality objective. And these are all institutionalized through clean air action plans. So on the, yes, so a clean air action plan is important because it will enable government as well as wider stakeholders to mobilize resources in the most effective and efficient manner to achieve air quality objectives. Okay, and I would like to share just some examples of how some cities have, or a country has set an air quality objective. So some air quality objectives are qualitative, but others are quantitative. So they set a specific numerical target. So this one is an example of a vision and goal statement and objectives in Bang City in Indonesia. So the vision is clean and healthy air in Palembang, and the goal is to improve air quality through implementation of science-based strategies for emissions reduction that contributes to public health and reduced environmental and climate change impacts. And the objective is to achieve and maintain air quality within the ambient air quality standards with the indicator of performance at a minimum of 340 days in a year complying with the national standards for criteria pollutants. So this is an example, and a an example which maybe several of you are familiar with is the China National Clean Air Action Plan, the first that they set. So as you can see, so this is the goal. They focused on overall national air quality improvement, drastically reducing polluted days, and they specify regional air quality in Beijing, Tianjin, and Hebei, Yangtze River Delta, and Pearl River Delta. And then they are very specific in their indicators that by 2017, the concentration of PM10 shall decrease by a certain percentage, 10% compared with 2012, and PM 2.5 in the three regions, the three prioritized regions shall fall by around 25%, 20%, and 15% respectively. So those were the indicators and the goal. And to achieve the goal and to, as evidenced by indicators, they came up with 10 measures. So these are called the national 10 measures. And the measures are listed here, which I won't go through, but these are examples of mitigation measures that a city or a country can uh, include in the action plan to attain the air quality. So I just point here this one on establishing the regional coordination mechanism and integrated regional environmental management body. I assume that in the previous sessions, you must have already learned that in some cases, actually in many cases, cities, a significant portion of the air pollution comes from sources outside of the boundary, the political boundary of a specific city. And therefore, a regional approach, an airshed approach is needed in order to be able to meet ambient air quality standards. So what are some good practices for clean air action planning? These are some of the good practices. So of course, first, drawing on the science that we know about air pollution in the city. And this is taken from your air quality monitoring, from your emissions inventory, from source apportionment that may have been done, or exposure assessments. And and then a good clean air action plan also evaluates the mitigation and control options, um, looking at their technical feasibility, their cost effectiveness, and ease of implementation. A plan sets a target and sets timelines for action. It is participatory, meaning major stakeholders are involved in developing the plan and in implementing the plan. And it also includes details on implementation arrangements. So which institutions are going to be involved, what partnerships are we going to enter into, are we going to partner with academic institutions and private sector or other organizations. And it considers the future scenarios. It plans for the future. And there is a monitoring and evaluation mechanism so we can assess our progress. And it is periodically reviewed. So the Clean Air Action Plan includes short-term measures, medium-term, and long-term mitigation measures. And there are different types of mitigation measures that you can include in an action plan. So these types of measures include conservation measures or efficiency measures, abatement measures, fuel switching, demand management, or behavioral change measures. Now, if we go to specific sectors and the measures, mitigation measures that can be implemented, so I have here an overview of control measures for transport emissions. And these include emission standards, cleaner fuels, fuel efficiency, and inspection and maintenance and transport planning. So um, if you can see at the top of this table, we actually have two types of measures. So the regulations, or these are your usual command and control measures, and the economic measures. So the economic measures are market-based instruments, usually using taxation or fiscal incentives to change behavior towards more air pollution reducing actions. So I maybe one way to best illustrate the mitigation measures relating to transport is by looking at a specific case. So I'd like to spotlight here the cleaner fuels and vehicles measures that were undertaken in all of Thailand, but which were measured, their impacts were measured in Bangkok. And I borrow here slides from Dr. Supat Wangwong Watana, former Deputy Director General of the Pollution Control Department of Thailand. So one of the policy measures that can be undertaken by the national government in relation to reducing emissions from the transport sector is by putting in place vehicle emission standards. And vehicle emission standards in many of the Asian countries have adopted the Euro system of the European Commission. And the higher the Euro number, as you can see here, the lower the permissible limits, tailpipe emissions are allowed of new motor vehicles. So if you can see here, in 1999 to 2000, Thailand was at Euro 1, and they moved to Euro 2, and then Euro 3 in the early 2000s. And from 2013 to the present, the standards, vehicle emission standards in place are Euro 4 standards, which are much stricter than pre-Euro and the Euro 1, 2, and 3. And alongside the vehicle emission standards are specific are specifications, fuel specifications that are aligned with the vehicle emission standards. So Euro 4 um, vehicle emission standards are matched with Euro 4 equivalent fuels. And usually when you go up higher in the Euro chain, in terms of fuel specifications, what occurs is that sulfur levels, for example, in diesel, become lower and lower as you go up higher in the in as you go to Euro 4 and higher. So what was the impact? We want to know whether there was an actual impact on ambient air pollutants uh, in Bangkok. And so we are very lucky that Bangkok actually has very good documentation of the impact of these measures. So as you can see, so from the early 1990s, you can see, okay, maybe I should explain the slide. So the 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 here that are going up are these are the vehicles in millions. So as you can see, from 1992 to 2018, you can see a significant increase in the number of vehicles. However, the lines from the left-hand side to the right-hand side, this is the concentration of pollutants in the air. No? So PM10, for example, you can see that while the vehicle numbers were going up, you can see that it is possible for your air pollutants, ambient air pollution in the air to be going down. And the Dr. Supat attributes that to the implementation of stricter vehicle emission standards and cleaner fuel specifications in Thailand. So as you can see here, the PM 2.5 concentrations continue to go down in Bangkok. Of course, with a slight increase in certain months, seasonal highs. And of course, NOx is also going down, very much linked to vehicle emissions. Well, SO2 usually is linked to because sulfur levels in fuels are also going down, so we can partly attribute that reduction also to the vehicle emission standards. As in many Asian countries, ozone remains a challenge. So other measures that are becoming really popular in the region is this shift to electric vehicles, to zero emitting vehicles. And of course, we cannot speak of electric vehicles in the region without highlighting the experience of Shenzhen. Now, Shenzhen um, is very proudly able to say that all of its electric buses, 100%, are all their public transit buses are electric, and the number now is at 16,000. And in addition to that, they have also reached 22,000 electric taxis. And they have a control center, and this is this photo is actually of their control center where they can track. So these small circles are all of the represent buses that are running. And as you can see here, their utilization rate is very high, or close to 100%, at least on this day. And click on each of these, you can see the condition of the vehicle, all of the vehicle information, its efficiencies, the battery capacity. So it's really just amazing. I included a link here for those of you who would like. This is actually a video, which you can view the impressive example or case of Shenzhen. And of course, other parts of Asia are following suit. We have Kolkata in India that has also started with 130 e-buses and wanting to do more. And in the Philippines, there is a city that is part of the metropolitan Manila. I cite this an example because of the unique application of electric two and three wheelers for parcel and small freight delivery. As we know, there has been an exponential increase in urban freight, small urban freight because of a lot of driven by a lot of online purchasing, and so this partnership delivery. So there's also a video there that you can view after this presentation. So there are other sources of pollution, and mitigation measures are needed to address them. So one is industrial sources, and among the measures include land use planning and zoning. So this includes uh, providing a specific industrial area or zone where industries can be located so that they can be monitored easily. There is a compulsory environmental impact assessment where they need to away from dense residential areas. Other
Miss Glinda,
Yes,
sorry for interruption. Can you switch off your video because we are losing your connection often.
oh, so sorry about that. Okay,
Yeah,
thank you for
switch
letting me
off your
know.
video
I
so
will.
that. Mm.
Okay, okay. um no, do I do that? Uh-huh. I think let me. Oh, I didn't know that. Okay,
Oh,
I got it.
okay. Yeah, done.
Okay, so yes. So for the other measures include promotion of cleaner production, and this is increasing the efficiency of industrial processes, improving the quality of fuels, and other mitigation measures include using best available control technologies, and imposing fines for violating emission standards and use of economic or market-based instruments. So I looked for an example, a good example of a uh, successful example of industrial emission control, which is also quite unique. This is the Gujarat Emissions Trading Scheme, unique in our region. So they are hailed as the world's first particulate trading system. And so this is a project that is being conducted in Surat, in Gujarat, in India. And they were able to, so the number of industrial plants in the city is about 317, and they're all connected to a continuous emissions monitoring system. So about half of the plants, 162 plants, are called the treatment group, and they have shifted into the new emissions market. And the rest are in the control group. They remain under the command and control regime. So initial results show that pollution in the treatment plants declined 24% relative to that in the control plants. And this decline was sustained during the 9 months life of the market until the operation ceased due to COVID-19 lockdown. So just showing here some resources that are available on Clean Air Asia's website on other means of reducing emissions through different mitigation measures. So for reducing air pollution from area sources, we have burning of biomass, open burning, forest fires, and dust resuspended from roads and construction sites. These are all examples of area sources. And measures to control these include enforcement of bans on burning of materials or waste, promoting alternatives to burning, better waste management, paving, use of street sweeping, and revegetation programs. So I'm on to my last few slides now, and really there later in the afternoon there will be a presenter on co-benefits of co-benefits measures, and this is just to say that co-controlling air pollution and greenhouse gases will be more effective than targeting each one individually. And this is true particularly in our region where economic and social development uh, are equally important priorities, together with climate change mitigation. So just some cross-cutting measures, which I think are important to implementing clean air action plans. It's raising awareness of people and building the capacity for air quality management. So even though this may not be direct mitigation measures, I think we should not forget that these are very important, to be working with people, increasing their understanding of why mitigation measures need to be undertaken. And many times we see that cities and countries, the technical capacity still requires a lot of strengthening. And so programs such as this one that's being undertaken by AIT are very, very important. And just to say, this last slide, that all of the mitigation measures that are in an action plan, if people are committed to implementing them, will result in reducing air pollution and reducing the mortality from air pollution. And this is a study that estimated the impact on mortality reductions because of reductions from ambient PM 2.5. So as you can see, from because of the 2013 action plan, there the outcome has been the reduction of mortality uh, of 1.4 million in 2013 to 1.1 million in 2017. And key factors in the reduction of health impacts was really implementation of emission control. Of course, other factors include meteorology change, population growth. And so I end with this slide just to say that clean air and blue skies are possible with clean air action planning and commitment to implementing the mitigation measures. Thank you. Back to you, Dr. Verma.
Thank you so much, Ms. Glenda, for your very nice presentation. You have shown a very good example of the implementation of policies and how the pollution reductions happen because of implementation of some good policies. You show an example of Kolkata, and then Surat, and China, and Bangkok. So these examples are very, learning lesson for other countries to learn that such policies can really impact can really influence the reduction of air pollution in the cities. So it was very nice information, very nice presentation with very good, very new informations on air, air pollution mitigation policy in Asia. So now may I request the participants to write your questions on Q&A box, and I will let Ms. Glenda to answer. We already have one question from Mr. Arvind Jha from CPCB Barodara. What are the key parameters to evaluate impact of measures taken in short term, whether or not no regret measures concept applies for short term measures? I think you can see the questions in your so should I?
No, I can't actually see the
Okay, let me
question.
repeat again. What are the key parameters to evaluate impact of measures taken in short term, whether or not regret measures concept applies for short term measures.
Hmm.
The question is
Oh,
little bit confusing. So let
yes, yes.
me,
The last part is a little bit but
yeah,
I think in general the question revolves around how do you assess the effectiveness of mitigation measures, but and I think there was an emphasis on short-term effectiveness. So
Miss Gilinda,
uh
you may open your video so that we can see you.
okay,
Hmm.
yeah. Because earlier I think the okay, yeah. Um yeah. So I think that there are several ways of monitoring of determining whether a measure has resulted in attaining the objective of of the specific measure. So that is why it's very important to have a monitoring and evaluation system in place, no? Because without no, first, for example, is knowing what is the starting point. So what is the baseline, either the baseline emission level or the baseline ambient air quality level that we seek to improve. Many times it is much easier to compute or to assess the baseline, to assess the emission reduction versus the ambient, the improvement in ambient air pollution. Because if you focus on the emissions, for example, if you're focused on reducing tailpipe emissions, then well, in terms of computing how much you would, how much is the emission reduction, that's much simpler than having to consider meteorology and other factors that affect ambient levels in the air. I mean, ambient air pollutant levels. So, of course, there are several measurement means of measuring tailpipe emissions, and it may require having to, sometimes you can do simply estimations. So for example, when you move from Euro 2 to Euro 4, you can actually estimate, if you know your vehicle fleet, you know the characteristics of your vehicle fleet, how many are diesel run, heavy duty, light duty, etc. How many are petrol run or gasoline run? And with the reduction of, and then you basically compute what is the estimated emissions coming from the shift from the more dirty fuels to the cleaner fuels, and then you're able to at least estimate, no, estimate what was the impact of the shift to cleaner fuels. Of course, if you would like to really know and measure real emissions, then you'll have to do tailpipe tests to really see what has been the change um, as you have changed the fuels. So yeah, I hope that answered your question.
I think so. Uh, Participants, please put your questions on chat box or Q&A box. We have still 15 minutes left for Q&A. Any more question from the participant side?
I think we have one question here.
Yes.
Mm-hmm.
How are we assured the industries or countries to do not falsify their results?
Ah,
How are
okay.
we assured that the industries or countries do not
Mm-hmm,
falsify their
mm-hmm.
results?
Yes, yes. So that is the function of quality assurance and quality control. So, and also can be a function of the use of the appropriate technology. So, I saw that in the earlier sessions there was a focus, I think on the first day, a focus on continuous emissions monitoring systems. So these systems link uh, uh, what most of the regulators do now is that there is already a control center in the, let's say, the central office of the Environmental Management Bureau, at the national agency, where all of the real-time emissions coming from a stack of coal-fired power plants or industrial plants, particularly large facilities, are all now connected and fed real time to the control center of the the National Environment Agency or the Regional Environment Agency. And in this manner, because the feed is real time, then there is less likelihood of um, yes, in the Philippines we have this term doctoring of the results. You mean, like fiddling with the results, or just submitting what you would like the authorities to see. So there's less tampering of the results because it's all real time. So that's one. And then second, even with the continuous emissions monitoring results, or even if there is a self-monitoring, because some countries or cities that have not required continuous emissions monitoring systems, they require the industries to submit self-monitoring results. And so usually these are paper results or results in an Excel sheet that are submitted by email. So what what needs to be done, if this is the system of monitoring, is there needs to be a quality assurance and quality control check, an analysis of the data that has been provided uh, by the industry. And then you will see, of course, by observation, you're going to see, for example, one that we were able to see. I'm not going to mention the country, but one result that we were able to see, that somehow the maximum emission levels always just end at the level of the standard. So if you plot all of the raw data, it almost like it just stops. The readings are all just stop at the maximum permissible limit. And so we were saying, how can that be? Usually you would normally see, okay, in some at a certain second or hour, that there would be some data points that would go above the standard, right? But if you see these kinds of very suspicious data from your quality control and quality analysis from your QAQC, then definitely that's already, you need to be flagging, checking why the results are like this. And of course, there are even though you have a continuous emissions monitoring system in place, you also still need to check whether the point at which the sensor is located is in the right place. So otherwise, you're not going to get the real results. So I think, there are ways by which we can prevent this using technology and just your usual QA/QC QA/QC measures. Of course, there's always that surprise inspection to see whether everything is in place, and others, they have third-party staff monitoring firms that go and visit and certify, at a certain occasion or certain date or time, that the emissions are at certain level. So yes, so I think these are um, some examples. Others have used drones. So there are those, because there were reports that some facilities, they turn off their pollution control equipment if there is no inspection, because they want to save on fuel or whatever, no, or they want to save on power, electricity, or certain fuels. But others have been able to monitor by using drones to see whether the pollution control devices are actually being used.
The next question is, what can we do to prevent air pollution caused by forest fire, since there is many sectors that involve in particularly like political interest?
Mm. Yes, thank you for this. Well, this is not a very easy question to answer, but because this has transboundary impact, then really the only way to go is to if this is across countries, as we experience here in Southeast Asia, then um, implementation of the transboundary haze agreement and cooperation among countries in terms of just monitoring, for example. So I think the satellite monitoring that is being spearheaded by Singapore, and the cooperation among the countries to alert each other if there is a fire that is spotted, is key. Definitely more, I think, needs to be done. We know that there is also a private sector responsibility on this issue, and therefore bringing in the private sector to become champions to ensure that their operations do not result in forest fires, I think is key. Um, yes, I can also imagine that empowering the community that live very close to where these occur, because they're the most they bear the brunt of the impact, would also be very important. Uh, so I think working with the people and with all of the stakeholders, including with government, uh, would be necessary in this case.
The next question is, the Clean Air Action Plan is dynamic and city status keeps on changing. Is there any way to understand which measures need to be dropped and which need to be more emphasized?
Yes. So everything will have to be based on the scientific knowledge that you gain through the assessment measures. So first, if you remember on day one, many of the scientific or evidence gathering activities were explained: air quality monitoring, source apportionment, emissions inventories. So this has to be done periodically as well. And based on what we find, so the major sources may change depending on how successful you were in mitigating certain emissions from certain sources. So again, we go back to the science. What does the science say now? Is what does the scientific evidence say as the main source now of pollution that we need to address? So the actually the air quality management framework is a circular framework. So after you have implemented the measures, you monitor and evaluate, and then you go back again to conduct evidence gathering to see what still needs to be done. So you go back through the cycle again of um, identifying the sources, monitoring air quality, and then coming up with mitigation measures, implementing them, and then assessing uh, progress. So I think yes, we go back to the
Um,
science.
the next question is the third party monitoring are paid by the industry. Is it possible to have a mechanism to minimize the perceived incentive, that is to pass the industry, since they are since okay, the question is okay, since they are your client essentially.
Mm-hmm. Yes, yes, that is a problem because uh, third party yes, third party tests are essentially conducting a service for a client who needs to submit the result to the regulator, to the Environment Agency. So, yes, that is a difficult question, but I think, very good QA/QC of the stack emission results will also show whether the certificate is believable. If certain, because I think one thing is important. We must be very clear as regulators what information we need in the emission certificate. You know, some of the certificates that we have seen don't have the key information that a regulator needs to assess whether the industry is actually complying. So certain, I think the templates must really be clear about the certain information, whether an oxygen correction factor was applied, etc. And then whoever receives the results should really check if the information is complete. And if the information is not complete, then it has to go back and be a test has to be redone. Um, really treat the certificate really seriously if this is the way that we want to monitor, and then maybe penalize those third-party stack testers that are found to have them explain why is it that we notice that for this facility the results are always the same. I mean, like have them, be accountable for the certificates they issue.
Yeah, last question. I think we do not have much time. When Euro 4 emissions level are introduced for vehicles, how vehicles should be tested using chassis dynamometer for whole
Mm.
vehicle fleet in a country?
Okay. That is a real challenge because chassis dynamometers, of course, they're not cheap, and to have that available all throughout the country can be quite expensive. So so what others have done is to I mean to partner with the private sector, but still have a centralized system of vehicle inspection and maintenance. Um, so one of the key lessons that the from vehicle inspection and maintenance is, you know, the larger the investment is made by the vehicle inspection company, the greater their incentive to perform well. If you have small operators of vehicle inspection and testing, systems, and their investment is not very big, then there is less risk for them if they don't perform according to standard. So so first is because this is a matter of where will the money come from to set up the equipment for vehicle inspection and maintenance. We'll need to really see if private sector can be contracted to do the service. But ensure that you have in place systems that reduce potential corruption in the system. But I don't think that I know that not in all cases do you need a chassis dynamometer. I know there are simpler systems that you can use, but of course, if we want to have the gold standard, then you would have yes, a chassis dynamometer would obviously give you a better results.
Thank you, Miss Gilinda. We do not have time for more questions for your presentation. So we shall move to the next presentation. Thank you for your nice presentation and um, uh, giving the valuable time for this workshop. Thank you so very thank you for so much for your contribution. So
Bye bye.
we move to the next presentation. That is from presentation on the air pollution mitigation policy module. The presentation is on air pollution linkages, air pollution and climate change linkages by Professor Toshihiko Takemura from the Kyushu University, Japan. Okay, professor is here. Professor Takemura is a distinguished professor at the Research Institute for Applied Mechanics, Kyushu University, Japan. He obtained his Doctor of Science degree in 2001 from the University of Tokyo. His research field includes numerical simulation of climate change and air pollution caused by atmospheric aerosols. He is very highly cited researcher in the world for several consecutive years. For example, from 2014 to 2020, he received Japan Academy Medal in 2019. He is a lead author of the 5th assessment report of the Intergovernmental Panel on Climate Change, that is IPCC 5. He is a member of the science panel of the Asia Pacific Clean Air Partnership, that is APICAP. So Professor Takemura, the floor is yours. Thank you for joining. Thank you for your time.
Okay, can you hear me?
Yeah, we can hear you.
Okay, good afternoon and good morning. So I'm Toshi Takemura from Kyushu University in Japan. So actually, I'm in Fukuoka, Japan. So where is currently in the middle of a typhoon, actually, although it is not strong. So it is very rainy and windy outside now, actually. Anyway, so actually, I gave a lecture last week in the training workshop of APCAP, Asia Pacific Clean Air Partnership Joint Forum. So if you attended the lecture last week, please think of it as a review of my lecture. So this presentation is based on the UpCap policy brief already issued and can be downloaded from this link. Please download if you are interested. So, but today's lecture contains more detailed explanations and updating information than the policy brief. So the main contents are the scientific basic information to you in order to understand why the co-control between air pollution and climate change is important, including mechanism of climate change due to short-lived climate forces. That means there are atmospheric aerosols and trace gases. And the latest scientific evaluation of the effect of short-lived climate forces on climate change. When we talk about climate change, we tend to focus on changing in temperature and precipitation. But the changing in temperature and precipitation are the end results, actually. So the basis for considering the issue of climate change is the energy balance, as well as various physical phenomena. The Earth tries to maintain its balance by receiving energy from the sun and emitting infrared energy to the space. So as you know, greenhouse gases change the energy balance by absorbing the infrared radiation and then actually isotropically re-emitting the infrared radiation from the greenhouse gases to space. And on the other hand, suspended particle matters, aerosols, change the energy balance mainly by scattering and absorbing sunlight. So in this slide, the energy imbalance due to human activity is 0.6 watt per square meter, but it is estimated that more than 2 watt per square meter of energy is currently stored in the Earth extra due to human activities. That is a current situation, more than 2 watt per square meter. The overall global average is about 240 watt per square meter of energy being exchanged by receiving energy from the sun and emitting infrared energy. So that the current climate change induced by the imbalance of about 2 watt per square meter is occurring with about only 1% energy shift. That causes the current climate change. So that let's review the mechanism of climate change caused by greenhouse gases. The main greenhouse gases that need to be considered in the current climate change are not only long-lived CO2, N2O, but also short-lived climate pollutants, SLCPs, of methane, HFCs, and tropospheric ozone, all of which absorb the specific wavelength infrared radiation. So, water vapor is also one of the important greenhouse gases. But direct emissions of water vapor from fossil fuel consumption and forest fires do not need to be considered because there is originally a large amount of water vapor in the atmosphere. But on the other hand, it is an important point, the process of acceleration of global warming by increasing the amount of water vapor in the atmosphere that can be contained in the air due to the temperature increase is very important. So this is one of the feedback mechanisms of climate change. So as explained in the previous slide, the role of greenhouse gases is absorption of infrared radiation from the ground, sea surface, and atmosphere, of course, and then re-emit the infrared radiation isotropically. For example, as shown in the right figure, right animation, if each CO2 absorbs 24 unit infrared radiation from ocean, land, and atmosphere, CO2 re-emit the same amount of infrared radiation isotropically. The numbers are hypothetical numbers for quantitative explanation. Then the outgoing radiation is 12 multiplied by 3, then 36. If greenhouse gas increase in the troposphere, extra infrared radiation is absorbed by the greenhouse gases, and then re-emit infrared radiation isotropically. Then the outgoing radiation is reduced to be 24, 12 plus 6 plus 6. In order to balance with the incoming solar radiation energy that is basically constant, the outgoing infrared radiation have to increase. Here, we need knowledge of the Stefan Boltzmann law. The energy emission from a material is proportional to the force power of temperature. For example, an infrared camera uses the Stefan Boltzmann law to measure the temperature of an object. From this law, we can understand that an ability of infrared emission is stronger if the temperature is increasing. Then heat is transported from the ocean and land surface to the atmosphere by convection. In fact, global warming caused by greenhouse gases cannot occur without convection. The decrease in the temperature with altitude in the troposphere is an absolute requirement for convection. This results in the temperature increase. That is global warming. For example, the emitted infrared radiation increases from 24 to 32, upward from 12 to 16, and this one is upward from 6 to 8. Then total changes from 24 to 32. But the outgoing infrared radiation is not back to the normal rapidly. Normal condition is in the figure of 36. So this is because the CO2 concentration rapidly increases by human activities before the energy is balanced, and because the ocean temperature change is very slow. So, and over 90% of excess energy due to human activity is stored in the ocean. Okay, that is a basic scientific explanation of climate change due to greenhouse gases. So the next slide, I'd like to explain the mechanism of the effects of suspended particle matters, aerosols, including PM2.5, on climate change. The major aerosols in the troposphere is sulfate, organic matter, nitrate, black carbon, soil dust, and sea salt. The mechanism is categorized by the aerosol radiation interactions and aerosol cloud interactions. The first one, aerosol radiation interaction, is a change in energy budget by scattering and absorbing solar radiation. You know that high PM2.5 concentrations cause haze in the atmosphere, of course. That is actually the aerosol radiation interaction. You can see the aerosol radiation interactions. The transparent and white particles scatter the solar radiation. On the other hand, dark aerosol particles, such as black carbon, absorb the solar radiation as well as scatter the radiation. And this absorption additionally changes the atmospheric stability in the vertical directions and ability of content of water vapor. This is additional phenomena. So so next one is this aerosol cloud interaction. The aerosol cloud interaction has to do with the fact that clouds cannot form without the presence of aerosol particles. In terms of the microphysical aerosol cloud interactions, the size of cloud droplets is getting smaller with increasing aerosol particles. That results in the enhancement of scattering sunlight by clouds. And then the small cloud droplets are also thought to change the cloud lifetime and then bring about changes in precipitation. That's the basic information of aerosol cloud interactions. Additionally, hydrophobic aerosol particles act as ice nuclei of ice clouds, which freeze supercooled cloud droplets. Water clouds and ice clouds have very different properties with respect to solar and infrared radiation. There are also some other climate change mechanisms by aerosol particles. For example, reducing reflectance due to dirt and melting snow and ice by deposition of dark aerosols, such as black carbon. Those are the mechanisms of climate change due to aerosol particles. Okay, so for example, to calculate and evaluate the aerosol effects on climate change quantitatively, I have developed a global aerosol climate model named Sprinters. This software is incorporated into a Japanese climate model, Miroku, and an Earth system model, Miroku ESM. Although I cannot explain in detail due to time limitation today, Sprinters calculates aerosol transport processes of emission, advection, convection, diffusion, sulfur chemistry, wet deposition, and dry deposition for main tropospheric aerosols of sulfate, organics, black carbon, soil dust, and sea salt, as well as their precursor gases. Sprinters also calculate the aerosol radiation and aerosol cloud interactions explained in the previous slide to calculate climate change by aerosol particles. So this is just an introduction. I have operated aerosol forecast system, including PM2.5 and dust since 2007, voluntarily using the Sprinters model I have developed. Based on the calculation results, it showed the predicted concentrations of PM2.5 and dust for each prefecture in Japan in 4 levels, and also displays animations of their transport in the Asian region and the global scale. The forecast information is provided through not only the website, but also newspapers, TVs, smartphone apps, and so on. This is a direct contribution to the public from the scientific achievement. So, and this movie is an example of simulation of global aerosol transport by the Sprinters model. This simulation treats both natural and anthropogenic aerosols. You can see that the spatio-temporal variability of aerosol concentration is very large, and aerosol lifetime is short. So you can see the transport from the Asian region to the Northern Pacific Ocean through Japan, and also dust emission and transport from the Saharan and Arabian deserts, and sea salt transport over the Southern Ocean, and also, and so on. Anyway, so you're interested, you can watch it on YouTube site. Please see later. Okay, so the next slide, this is a latest evaluation of each climate forcing agent by human activities, including short-lived components, in the IPCC 6th assessment report, published in the last month. Actually, the UpCap policy brief includes a diagram based on the previous IPCC assessment report, but the diagram on this slide is the latest version. This shows that the global and annual mean changes in the energy budget, named radiative forcing, divided into the emitted compounds, indicated in this left column. The colors of each bar indicates components in the atmosphere, which means that the emitted components can transform other ones or themselves with chemical reactions and through chemical reactions. So, of course, CO2 is a primary contributor to anthropogenic climate change. But you can see that the short-lived components, short-lived climate forces also largely contribute to the climate change. So this methane is the next largest positive energy budget due to not only the greenhouse effect by methane itself, but also contribution to tropospheric ozone production shown in green one, through chemical reactions with OH radical and an increase in stratospheric water vapor. For CFCs, HCFCs, and HFCs, this evaluation includes not only a direct warming by themselves, but also a destruction effect of CFCs and HCFCs on stratospheric ozone. That means ozone hole, shown in the green one. That means that results in the negative forcing. Next, NOx. Nitrate oxide is a precursor gas of ozone, shown in green one. That is both an air pollutant and a greenhouse gas. But it is complicated that an increase in NOx results in the reduction of methane, shown in the red, orange one, due to an increase in OH radical, which results in atmospheric cooling. So that is so complicated. Next one, VOC is a precursor of tropospheric ozone, and VOC and CO, carbon monoxide, increase methane through chemical reactions with OH radical, shown in orange one. And it is very important that also have the large effects on negative energy budget, explained in the previous slide. For aerosols, the color bar are divided into the aerosol radiation interactions and aerosol cloud interactions. So sulfate aerosols produced from SO2 is a primary contributor of negative forcing through the aerosol radiation and aerosol cloud interactions. We have to understand that the emission reduction of SO2 is essential for mitigation of air pollution by PM2.5, of course, but it results in reducing the cooling effect. Organic aerosols also have the negative radiative forcing. On the other hand, black carbon has a positive radiative forcing due to the absorption of sunlight, as explained in the previous slide. Here is a quick check on terminology. So you can hear that short-lived climate pollutants and short-lived climate forces. It is so the close one, but it is a little bit different, actually. So short-lived climate pollutants, SLCPs, usually refer to short-lived substances with positive radiative forcing, which are defined by Climate and Clear Coalition CCAC as methane, HFCs, tropospheric ozone, and black carbon. On the other hand, short-lived climate forces, SLCFs, refer to short-lived substances that cause climate change regardless of their positive or negative radiative forcing. And the IPCC uses the term short-lived climate forces, SLCFs, in the IPCC report. So short-lived climate pollutants with positive radiative forcing are easy to understand as co-benefits that can mitigate both air pollution and global warming by reducing their emissions. On the other hand, substances with negative radiative forcing, such as SO2, NOx, and organic carbon, as shown in the right figure, will improve air pollution if their emissions are reduced. But they will lose their cooling effect, which will accelerate global warming under the condition that CO2 continue to increase. In order to mitigate both climate change and air pollution, it is necessary to reduce emissions in an integrated manner, including CO2. That is the ideal reducing measures. Okay, so this figure shows a trend of global mean surface air temperature from 1950 to the present, indicating observations with black lines, solid black lines, and climate model simulations with shades, both human and natural sources in black shade, only greenhouse gas simulation in red shade, only aerosol particle simulation in blue shade, and only natural sources in green shade. The approximate agreement between the black solid line, that is the observation, and the black shading by climate models means that the climate model is able to reproduce real climate change. It also shows that the current global warming cannot be reproduced from natural sources alone, shown in green shade. And the current global mean temperature increase due to greenhouse gases is estimated to be about up to 1.5 degrees Celsius. But aerosol particles are estimated to have lowered the temperature by about 0.5 degrees Celsius, resulting in an increase of 1 degree Celsius in the present climate change, shown in the black shade. Most of the aerosol particles here are PM2.5, and although they cause air pollution, it is clear that they have played a role in reducing global warming to some extent. This right figure shows conversion from the energy budget change shown in the previous slide and to the surface air temperature change using a simplified energy balance model for each climate forcing agent, cited from the summary for policymakers of the IPCC AR6. It indicates strong suggestion of the importance of controlling SLCFs, short-term climate forces, for mitigating global warming. So the anthropogenic methane, halogenated gases, VOCs, and CO, and black carbon result in the temperature increase. On the other hand, anthropogenic NOx, SO2, and organic aerosols result in the temperature decrease. These temperature changes by each component are estimated with a actually simplified energy balance model. But actually, I am currently leading a research project to compute for each short-lived climate forces using the coupled atmosphere-ocean climate model. Is anyway, so this figure shows a strong suggestion of the importance of controlling short-lived climate forces, as well as CO2. So this slide shows the result from my latest study using a coupled atmosphere-ocean climate model. This figure shows a change in the surface air temperature due to complete removal of fuel SO2 emissions and the CO2 concentration of 369 ppm in the top panel, close to the present concentration, and twice that at 738 ppm in the bottom panel. Even with the same amount of reduction in SO2 emissions in the both panel, the higher the CO2 concentration, the greater the temperature increase. This indicates that if SO2 emissions are to be reduced in air pollution control, so actually it is important to keep CO2 concentrations as low as possible for mitigating climate change. So the message is a simple emission reduction of short-lived components result in clean air, of course, while contributing to global warming. So it is essential to consider mitigation both air pollution and global warming simultaneously. This right figure shows a change in the surface air temperature by the vertical axis with a change in the energy budget change by horizontal axis for sulfate and black carbon aerosol particle. Sulfate is blue lines and the black carbon is shown the red line. In the previous slide, the simplified conversion from the energy budget change to the temperature, cited in the IPCC AR6. But actually, this figure indicates that the temperature change by a vertical axis with the energy budget change by horizontal axis much depends on chemical components, much different between the sulfate aerosols and the black carbon aerosols. So because climate change research on short-lived climate forces is a rapidly progressing field now. So, if possible, please refer to latest scientific evaluation. So, I'm leading a research project under the Environment Research and Technology Development Fund of the Ministry of Environment Japan, which is a comprehensive research focusing not only on climate change due to short-lived components, but also health, agriculture, and water cycle impacts due to short-lived climate forces, and then proposing their optimal reduction pathways. This project aims to contribute to international and domestic mitigation policies on both climate change and air pollution implemented by such as UPCAP and CCAP. So this slide is a summary of my today's talk, which can be found in the UPCAP policy brief I authored. So this figure shows the complicated and comprehensive relationship among short-lived climate forces for climate change and impacts on human health and crops. The square represent the gases, and the ellipses represent aerosol particles. The arrows indicate various changes if emissions of short-lived climate forces and their precursors increase. For example, the red arrows mean the temperature increase and negative impacts. For example, black carbon warm the atmosphere and the methane and ozone warm the atmosphere, showing the red arrows. And negative impact of human health due to increase of short-lived components, of course. And on the other hand, the blue one means the temperature decrease For example, due to increase in sulfate, nitrate, and organic carbon, so that result in the cooling effect to the atmosphere. So, if emissions of short-lived climate fossils and their precursors are reduced, the impact are reversed from this panel. So anyway, so it is very important to consider this comprehensive relationship for planning mitigation measures. That's all. Thank you for attention.
Thank you, Professor Takamura, for your very nice presentation. It looks like we were sitting in the graduate classroom. I remind my PhD this at the University of Tokyo, Hongo campus, where I used to attend such a very, very good lectures from the professors. So thank you so much for your nice presentation.
Okay, you're welcome.
Yeah, so may I request the participants to write your questions on chat box or Q&A box so that we can have an answer from Professor Takamura. Maybe the participants will have some time to assimilate your very complex presentation.
Yes. But actually, I think that scientific information is a very basic information
very
for the
basic.
mitigating, considering the measure of the yes.
Yeah. There is a question from
one question. Yes.
Professor John. Yeah. Do you know the relative contribution of CO and non-methanogenous volatile organic carbons to warming in the new IPCC?
Okay. So, for example, yes, this one or this one. Yes. Okay. Okay. So the relative contribution. Okay. So yes. You mean that this figure show the some effect of NMVOC plus CO. So the okay. So relative contribution between the CO and VOC. So yes, of course, the it is not shown in the panel, but probably the each number is shown in the table in the report. Probably, yes. But I actually I have not checked it. I'm sorry about that. So you can see actually you can download the IPCC latest report from the IPCC website. So please check the information.
Okay. Any more question from participants? We still have 15 minutes for Q&A. There is a question. Generally, air quality is not addressing greenhouse gases. How the air quality action plan will target climate interfering gases?
So, I'm sorry. I cannot understand the meaning of the question.
Okay, let me try to say again.
Uh-huh.
He want to ask the since air quality is not addressing greenhouse gases emission reduction, how the air
Uh-huh.
quality action plan will target the climate interfering gases. So how the air quality plan can also address the greenhouse gases emission reduction.
Yes. Uh-huh. Okay. So yes. So it's very difficult question to answer. Yes. So the even in the now developed countries, as you know, basically there are only air quality measures. For example, the introducing end of pipe measures. That is actually only mitigating air pollution only. So actually, the for the view the in the view of the mitigating climate change issues, so actually it was not good measure actually, only reducing the air pollutants. So in the near future, not only developing countries, but also developed countries have to make a strong measure, not only our air pollution, but also the reducing climate change. So that is the problem, even in the developed countries, actually. So that is the future uh, uh, problem. So to make good and better measures, both for the air pollution and climate change.
Okay. Any more question from the participants?
So
We
but
still have about
I mean national standards are for pollutants, but not GHG. Uh-huh. Okay. So yes, and yeah, so for the is okay. So I can just probably understand. So national standards in the each country have only for pollutants, so shortly pollutants now. So on the most country have not the national standard or concentration of greenhouse gases, of course. So yes, so that it is difficult to measure the national standard for greenhouse gases because basically CO2 is a primary greenhouse gases, but that is a very long time lifetime. So that is a well mixed in the atmosphere. So it is not local. So it is difficult to measure the concentration standard of greenhouse gases actually. So, but on the other hand, for the climate change measures, so we have to report we mean the each country. Each country have to report the emission amount of greenhouse gases to the uh, UNFCCC, So it is the other standard, I think. So the Paris under the Paris Agreement, each country have to propose the aim of the emission reduction of greenhouse gases. So each country have to pursue that aim. So that means it is I think that close to the national standard, I think.
okay. I think no more question from participants. If there is no more question from participants, so thank you so much, Professor Takemura, for your
Thank you
very
very
nice
much.
presentation. Thank you so much for your
Thank you.
contribution to the workshop. So we
Uh-huh.
still running fast at 10 minutes. So I can invite the next presenter, the third presentation of the workshop on the air pollution mitigation policies module. And this presentation is on the long range energy alternatives planning integrated benefits calculator, that is LEAP IBC, from Dr. Johan C.I. Kulestriena from the Stockholm Environment Institute, York Center, Department of Environment and Geography, University of York, Haslington, UK. Dr. Johan is a research leader at the HCI and a member of HCI's Global Research Committee and a reader at the University of York, UK. He is a member of the Scientific Advisory Panel, Sept, of the Climate Clean Air Coalition. His key areas of interest related to the integration of strategies to address climate change and air quality, in particular associated with strategies to reduce short-lived climate pollutants, SLCPs. He is a part of a team developing on SLCP strategy support tool, that is LEAP IBC, being used by many governments to develop national integrated air pollution and climate change mitigation strategies. He also contributes to assessing impact of air pollution on human health, such as on preterm birth and asthma. He coordinated a UNEP WMO integrated assessment on black carbonate tropospheric ozone. He is an author of the CCAC UNEP Global Methane Assessment, Benefits and Cost of Mitigation Methane Emissions. So, Dr. Johan, the floor is yours.
Thank you very much. So can you hear me well?
Yeah, we can hear you.
Very good. Well, thank you very much for this opportunity to talk at this excellent workshop. And I really enjoyed the last two presentations, and hopefully what I'm going to talk about is going to feed off both of those. Thank you for that very long presentation. So my name is Johan Schülencharner. It's a very difficult name to pronounce, but I work for the Stockholm Environment Institute, and we collaborate with a lot of people, including Glinda and others, and a lot of the work I've been doing is related to the Climate and Clean Air Coalition in terms of their activities, but also in terms of being part of the scientific advisory panel. So what I want to do now is to lead off the last presentation, which emphasized the need for us to take integrated approaches. And not only do we need to develop these integrated approaches at global scales, but also at national scales. So I'm going to look at how integrated approaches can be developed by countries. So I presume that you can see my slide.
We can see.
That's good. So first of all, I just want to go into some context. So we've just heard about the mechanisms of how the planet is warming, and we all know that there's going to be the next COP26 in Glasgow in just over a month's time. And you know, we should have had last year all of the updated NDCs. You know, some of those are still coming through, the nationally determined contributions. And by 2025, which is only just over three years away, we need a new set of nationally determined contributions from countries, which are going to outline the steps that they're going to take. to address climate change. Now, we've been involved in helping some countries develop their NDCs, and what is clear is that there are many countries who still are not in a position to undertake analyses themselves, and also not in a position to integrate the issues that Professor Takamura mentioned in terms of integrating air pollution, climate change, and other issues. So that's one part of the context. The other part of the context, as we've just understood, is that air pollution and climate change are really very linked. And then we have the short-lived climate pollutant issue as well. And not only are they linked in terms of the effects on the atmosphere, but they're also often co-emitted from the same sources. And so if you're going to address, implement policies such as the one that Glinda talked about, then you can't help but affect both the greenhouse gases and the air pollutants at the same time, or at least you have the opportunity to do so. And we have lots of different benefits, or impacts or benefits depending on which way the emissions go. So we can address the long-term warming, the near-term warming by addressing the warming short-lived components, as has been described. With ozone, we can look at health and crop yield decreases, and then the substances that give rise to PM 2.5 is the biggest impact on health. So if we look at the PM 2.5, now this is really important for human health. It has many, many different impacts. And we can see that, there are some positive messages here. This is from the State of Global Air. You can find that on the website. And, we showed Thailand, the whole of East Asia and Southeast Asia. So Southeast Asia, Thailand gradually going down, but still as a population weighted mean, twice the current WHO guideline of 10 micrograms per meter cubed. And then we know that in China there have been some dramatic efforts to decrease air pollution, and that's been having an effect, but it's still a problem. Now this is the figure which comes from the CCAC and UNEP solutions report, which many people were involved with in Asia and internationally. So the first thing is, here we have the PM 2.5 concentration, and we have the 2015 figure as a population weighted mean for the whole of Asia. And this would have increased if policy hadn't been taken. So at the time, when this was made, if we look at the already implemented measures, that means that this amount of decrease has occurred. If all of the legislation which has been already agreed is implemented, then we have a decrease to about the same level that we were in 2015 by 2030. So that is a big benefit, and there's a lot of credit for the efforts that have been made, but it doesn't make the situation better. And of course, with an aging population, we end up with more health impacts than we would have had otherwise. So even with the same level of air pollution, we have more deaths, more health impacts, because people are getting older. But there's a big potential then to address air pollution through other measures. And if we are clever about it, we can find measures which can reduce both the warming and the health impact of air pollution. And this is some work that was looking at the NDCs and also efforts to reduce or limit warming to the 2 degrees C of the Paris target. Now, with the level of NDCs, this is the 2015 NDCs, then about almost 500,000 people by 2050, there would be 500,000 fewer people dying early, so dying prematurely. But if we were to mitigate for climate change to achieve the 2°C target, then that would be avoiding the deaths of a million people every year. So clearly, these issues are very linked. And another linkage comes through methane. So we've already heard about the fact that methane is an important precursor of ozone, which gives rise to these losses of crop yield. But also the ozone affects respiratory health. And we can see it's coming from agriculture, fossil fuels and waste mainly. And this is the result from the global methane assessment that was mentioned earlier. So, methane being one of the most important greenhouse gases, if we were to reduce emissions globally by 45% compared to what they would have been in 2030, then we can reduce the warming around 2040, 2050 by about 0.3 degrees C. And this is one of the aspects of the short-lived climate pollutant issue, is that these are relatively short-lived in the atmosphere, which means that the climate response is faster than if we address CO2, because the methane concentrations in the atmosphere will respond within a 10-year, 10, 20-year time frame. So we can avoid warming by addressing methane. But because of the strong link between methane and ozone, we can also avoid about 250,000 deaths a year. But there are other impacts. We often talk about premature mortality because it's the strongest relationship we have with air pollution. But there are other non-fatal outcomes, and more people are affected. So we could avoid over 770,000 visits to emergency rooms, to hospitals every year, which are caused by asthma attacks. So, that's a big impact on well-being. And then also we can avoid crop losses. So this is 26 million tons a year of only 4 staple crops. That's the yield loss avoided. But also, the heat, the avoided impacts due to increased heat around the world is estimated at 73 billion hours of lost work hours due to heat stress. So there are lots and lots of, not only are the substances linked, but also the impacts are very diverse and affect both health, well-being, and productivity. So, this just emphasizes that just looking at methane, you're dealing with air pollution and climate change and a host of different impacts that are important. So this is a figure which is from the CCAC, the Climate and Clean Air Coalition Scientific Advisory Panel, and it's saying that if we can address the short-lived warmers, we can have a lower rate of warming. We can't stop it, but we can have a lower rate of warming than if we didn't address them. And for all of these reasons, affecting agriculture, healthy lives, if we want to achieve the SDGs, there's a big synergy here in addressing these issues, these substances. But if we're going to get action to happen, we need countries to be able to analyze these sorts of strategies, the effect on emissions, the effect on impacts, so that they can advise their decision makers on those strategies which can really provide a big global but also local benefit to people's lives. And we think it's really important to make sure that the capacity to undertake these analyses exists within countries, so that people, experts in countries, experts within ministries are able to understand how these analyses are put together and better advise their policymakers, be more convincing about the opportunities that exist to improve matters. So really, we need to enhance capacity. And this is a photograph of all of the people around the world, from Asia, from Latin America, from Africa, who are involved in a program with the Climate Clean Air Coalition on national planning. So I'm going to talk about that effort. So under the CCAC, there is a national planning initiative. We develop support for the whole of the national planning process. We have tools and guidelines which can be used to inform the planning process, and that's what I'm going to talk about soon. We have regional workshops so that people can share experience, and also, you know, there is a need to strengthen institutions. I mean, without strong institutions with the capacity to undertake analyses, I don't think there's going to be as much change as we need. And these are some of the countries that we're working in. We're also working now with Clean Air Asia in Pakistan, for example. We've got a small project in India, and we've worked in Nepal as well. So there are other countries in Asia which are not represented here. And we're also doing a project with UNEP in Seoul in Korea. And you can't see, but we have worked with the Maldives as well. And for a number of these countries, they've decided that the best way to promote the mitigation is to develop plans. So some of these plans focus more on air pollution, such as in the Maldives, and some of them focus on the short-lived climate pollutants. But all of them have undertaken an integrated air pollution and climate change analysis to come to the conclusions about additional actions that they need to take. So what I want to talk about is, you know, the analysis that has supported countries and the tool LEAP, which has been used to enable countries to develop those analyses and develop quantitative scenarios to help the planning process. So this will not be unusual for you, but essentially, you know, we're talking about understanding how emission changes in the future will change the future situation. So we have a baseline trajectory. In many countries, emissions are still going up, other ones are going down, but we can take additional action and we can lead to mitigation in these different sectors. So this is the sort of output we can get from LEAP at the end of the analysis. So what is LEAP? So LEAP is the Low Emissions Analysis Platform. It's been created by the Stockholm Environment Institute, and it started life as an energy system modeling approach, and it's been used by hundreds of countries to look at energy balances to inform energy strategies, and then it quickly evolved into a GHG emission mitigation tool, and was used by countries to inform their planning on GHGs. And then what we've done is we've added the short-lived climate pollutants and the air pollutants to this. So it's been informing decision making for about 30 years now. There is a community. I'll show the website later. There's about 27 or 30,000 people in that community. It's widely used. So it's been developed to be useful, especially in developing countries, but not only in developing countries, and especially to make sure that they can perform their own analyses. And it's well suited to long and medium term national planning. One thing to say is that LEAP itself is not a model. It's not, you know, LEAP says this or LEAP says that. It's a tool to enable people to create their own national models. So it provides quantitative assessments. So it develops the emissions, but if we want to look at impacts, for example, on health, we need to understand how the emissions are translated into exposure. And what we have is a very simplified way of looking at the atmospheric transport and transformation using the results of the geoschem model. And from that, we translate the geoschem model results into simple coefficients that relate emissions to concentrations, and then we can look at health impacts. And we also have some calculations of how changes in emissions would affect global temperature. So if I go into some of the key characteristics of LEAP, it's very flexible. It can be tailored to different countries. Different countries have different amounts of data, but it can be tailored to the data that exists to allow people to start on this process of developing their own analyses. There are lots of different methods that are incorporated into it to allow different types of analysis, such as econometric analysis. You can do optimization. There are all sorts of things that can be done. It's very flexible and it's got a lot of tools associated with it. So there are, simulation methods which are embedded within a framework of emissions and energy accounting. It is a scenario-based tool, so it really is trying to make it a bit easier to assess the trajectory in the future. So you can develop scenarios for different policies compared to a baseline. You can clearly show the assumptions, and one of the aspects is that it is very transparent. You can see the data, you can see the equations, and you can understand how you get the results. It's got a useful and powerful graphical user interface to get visualizations of future and current situations, and it can be used at various scales. So we've been using it at city scales, such as the work we're doing in Seoul now. Mainly it's been used at national scales, but we're also developing an Africa-wide LEAP assessment, which it has national resolution. And there is lots of default data in there. You can easily override it, such as the emission factors. If you've got better emission factors, you just double click on the emission factor and change it. And then we encourage people to write a note underneath so that within LEAP it says where the new emission factor comes from, so that if someone else comes along, they would understand what's been done. It has an annual time step with seasonal time of day details, and it is widely used for energy planning. It's been used in the national communications to UNFCCC to develop low emission development strategies and national action planning on the short-lived climate pollutants. And it's been used by about 30 countries in developing their NDCs. So if I go through some of the components of LEAP, so first of all, we have LEAP itself. So this is really where the calculation of the energy futures and the analysis goes on. So first of all, we have energy demand. So the energy demand is modeled in all sectors. And this demand then informs what you need to supply in terms of energy, in terms of electricity and other types of energy, wood fuel, etc. And the electricity is then, so essentially the energy transformation, or including electricity generation or charcoal making, is then matches the energy demand. And then you can say, well, what form of energy, electricity generation, for example, will that be in the future? Then from this, we can take the energy, so for example, electricity generation, tons of fuel times emission factor, and we get emissions, both of greenhouse gases and air pollutants, and it includes the short-lived climate pollutants, which are, well, short-lived climate pollutants are both greenhouse gases, and in the case of black carbon, a particle. So in this way, we can integrate the impact of changes to both the air pollution, and the climate change issues. And then one of the big issues in terms of human health is the use of wood fuel or other biomass for cooking in many parts of the world. And there is a big health impact due to exposure to particles in indoor air. So we have a separate indoor health impact calculation. And then the air pollution emissions move to the integrated benefits calculator, where the estimates of the impact on PM 2.5 and health occur. So I'm just going to go through those now. So from the LEAP analysis, we know the number of households that are cooking using different fuels and technologies. We look at the number of people in each household and the number of people using different cooking technologies. And then from an estimate of the PM 2.5 exposure in using different fuels and the sort of epidemiological exposure response functions and then national mortality rates, we can estimate the health impact. So then if we change the way in our scenario that people cook, this will have an automatic impact calculated on the premature mortality. How many people will die early under different scenarios? So that's a useful output which can, inform the strategy and inform decision makers. And then we take the emission, which is often for the whole region, let's say a country. We grid it using proxy data like population density. And we then have a nationally grid emissions, and we mix that with the results from the GeoSchem model, and we get a population weighted annual PM 2.5 concentration, and that's used to develop a health impact assessment. Again, at the moment, premature mortality, but other impacts can be assessed. And like I said, we can use forcing response functions to look at, in a simple way, the average change in global temperature, both from the greenhouse gases and from the aerosols. One thing I forgot to mention here is that, like I said, the LEAP is a scenario tool. So what we do is we have the ability to have drivers like demographics and economics mainly, which drive the development of different sectors, and then this is linked together to create the scenarios. So if you were to develop a LEAP analysis, what would you do? Well, the first thing to do is to gather historical data for a base year or base years going back maybe 10 years. The sort of data you would collect is energy demand and electricity production, but also the activity data relevant for non-energy sectors such as agriculture, waste, process emissions in industry. So from that, we can estimate the energy sector and the non-energy sector emissions by linking it to the emission factors for air pollutants, greenhouse gases, and short-lived climate pollutants. And so this gives a series, emissions for historical years based on hopefully, real data. But then we can develop scenarios. So we use that link to the drivers, like the number of people or the change in GDP, and develop baseline emission scenarios. And then we can look at mitigation options and see how those emissions change. And then we can look at the benefits as well. So this is what LEAP looks like when you open it on your computer. So it works on a Windows-based application. And you have these different views. So you have the analysis view, which is what we see here, but also you can look at the results as well. And first of all, we have a menu and toolbar to give access to lots of important options and like basic parameters to set up the LEAP analysis. we have data, and the data is organized in a tree. So here we have the demand. And so we model the demand, for example, in households, industry, transport, and the commercial sectors. And then we can change this, it's a very flexible tree structure. We can change this so that it reflects the structure of the data for whichever country you have. And then we have the transformation, so the electricity production to feed the energy demand, for example. And then we have the non-energy sector down here. So we can edit any data in here. It's just clicking on it and you can change it. You can select different units. And then you can view the data. So here we have millions of households. So we have a growth in the number of households of 3% per year, and it calculates how the number of households will change over time. So then we have a status bar with some notes and saying what we're looking at. So the tree structure is the, most of the work in developing LEAT is finding the data. So the data is organized in this tree structure where we can model how it changes, we can review results, we can edit it, we can change the structure, we can copy trees and move them, we can paste them, drag, drop. So it's got a lot of functionality to make this as easy as possible, but it's still a lot of work to find all of the data for all of these sectors, both non-energy, such as land use, agriculture, waste, as well as the energy demand and the energy transformation. So oil refining, electricity generation, transmission distribution, charcoal making, that sort of thing. And LEAP has embedded within it a lot of different expressions. So you get some simple ones, like, you grow something by 3%, or you can interpolate between different years. So you can say from the year 2010, it will then change to from 30 to 45 in the year 2014. It draws a straight line between them. So there are various functions which can be used, expressions. And so you can use these very simple ones, but you can also use the equations that equate to tier 1 or tier 2 IPCC methods. So then these expressions will then help you develop scenarios into the future. And then you can view the results. You can look at charts, tables, maps, different units of measurements, different types of charts, choose your colors, etc., etc. And then you can go up and down different levels and see different levels of disaggregation of data to the one that you want to do. And it's very easy to export the results into Excel and PowerPoint, etc. So let me just talk about the scenario analysis, because this is key. We know that the future is unknown, but we can still explore it using scenarios. So a scenario is really an internally coherent, physically plausible story describing a possible future. And so the scenarios are represented using exogenous data and hypotheses, calculation methods, and the results are produced from the data and methods used. But a scenario is different from an emission inventory. So your typical emission inventory is the emissions are calculated from some sort of activity data times an emission factor. And that's true for the greenhouse gases as well as for the air pollutants. So if we look at the residential sector, we can have activity, the amount of fuel consumed times an emission factor gives you the emission. So that's what is typically done in emission inventory, looking into the past emissions. So here we have that same emission inventory approach, but if you want to make projections, then you need to change this so that you can estimate the fuel consumption from data that you can look at in terms of how it changes into the future, such as the number of households and the amount of fuel consumed per household, how that changes into the future. You need to know the number of households, which is population times the average household size, which may change over time as people become more affluent, and the fuel consumption. So you need to understand how the population cooking using different fuels or technologies change over time and the average fuel consumption of that technology. So if you have those, you break this down into those types of data, you can then develop a scenario for that sector, and then you go through this for all sectors. So let me just go into case studies for the application of LEAP. We have written this up, so there is a description of the LEAP model and all of the calculations and the way it's set up in this paper, where we developed the analysis to support the short-lived climate pollutant strategy development in Bangladesh. So these are some of the results. So these are emissions of these different components. So we've got the black carbon, the methane, the directly emitted PM2.5, organic carbon, sulfur dioxide, nitrogen oxides, ammonia, the non-methane volatile organic compounds, carbon monoxide, and CO2. So in this, you can see that we have an integrated view of the emissions of greenhouse gases and air pollutants and the short-lived climate pollutants. And we have all of the substances which form PM2.5 and tropospheric ozone. And you will see here that we have the breakdown of where those emissions are coming from. So we have CO2, not surprisingly, from energy industries and manufacturing, construction, and transport and residential. So, you know, that's as expected, but we also have carbon monoxide, which is very much from the residential because there's so much cooking using biomass. And so we have that sort of detail for all of the different pollutants. Then, you know, as part of the planning process that was undertaken in Bangladesh, then going through, you know, all of the current strategies and then identifying gaps or identifying further things that can be done. And these are then, you know, some of the measures which are applied in the NDC and some applied in the SLCP action plan. So then we could look at what does the NDC do for these emissions and what does the SLCP plan do. So for CO2, not surprisingly, the NDC, no, CO2 is down here. The NDC reduces CO2, but interestingly, if you apply the additional short-lived climate pollutant actions, it also affects the CO2 emission because of the measures that were implemented. But obviously, with the SLCP measures, both the NDC and the SLCP measures reduce methane, but they also reduce nitrogen oxides and black carbon. And the NDC itself will reduce black carbon because these substances are co-emitted. And then we look at the local benefits for air quality and health using the integrated benefits calculator. So we can see that the ambient PM2.5 in the baseline would have gone up, but in the mitigation scenario goes up less, but it doesn't go down. And there is then an impact on premature deaths, but it's not linear, so it's not exactly the same as the ambient. And then we've got premature deaths from indoor air pollution. Now that really goes down as you know, shifting to LPG or another cleaner fuel. So let's look at some other examples. So these analyses have affected national policy. So in the case of Chile and their nationally determined contribution, they've said that they will recognize actions that mitigate short-lived climate pollutants that also contribute to limiting global average temperature, and they're reducing emissions of black carbon as well as, so this is in addition to the work that they're doing on mitigating greenhouse gases. So Chile has an NDC commitment on black carbon to reduce it by at least 25% by 2030 with respect to 2016 levels. So this analysis using LEAP has helped to inform this decision, where they can do this in addition to what they were going to do anyway. And these are some of the scenario results for Chile. You got black carbon here, organic carbon, PM 2.5. You've got a baseline. You've got, I mean, in Chile they have a carbon neutrality policy, and so you know, PM 2.5 goes down in the carbon neutrality policy, but then you have carbon neutrality plus, which includes specific measures on some of the sources such as heating with biomass, and it goes down even further. So these are the sorts of the analyses which have informed that decision making and the setting of a target for black carbon. There are 3 countries that have done so so far, and that's Chile, Colombia, and Mexico. And the other thing to say is that here many of the measures which they're looking at to reduce this are either cheap, negative, or negative costs. So, you know, there's a lot of evidence that can help to inform policy making. So now I want to look at some of the sharing knowledge and experience. So we've worked with about 30 countries, in more detail with about 16 countries, and we've tried to distill some of that knowledge. And there is a publication on the Climate and Clean Air Coalition website for opportunities to increase ambition and nationally determined contributions through integrated air pollution and climate change planning, a practical guidance document. And here within this, we can look at different opportunities. So, you know, including specific methane or HFC mitigation targets, including specific black carbon measures in the NDC, additional CO2 measures that achieve air quality and human health goals, and additional mitigation, fully aligning NDC with other strategies such as the Kigali Amendment. In some cases, you know, the NDC doesn't reflect other things that have been agreed by countries, and so there's really a chance to do that. So, and it's interesting to see that, you know, the countries I mentioned, Colombia, Chile, but also Dominican Republic, Mongolia, Bangladesh, Costa Rica, Rwanda, and also the UK, they've all submitted updated NDCs, including consideration of the health benefits related to climate change. So coming towards the end here, you know, we're continuously developing our analysis, because we feel that, you know, we need to be able to stack up all of the different benefits that come from a mitigation strategy. So, you know, one of the issues related to diet, agriculture, health. Now, obviously, agriculture and diet is heavily related to methane mitigation. 40% of anthropogenic methane comes from the agriculture sector. And eating less meat, less beef, is going to reduce the amount of methane. But also, if we can quantify the other benefits, well, first of all, make sure that, you know, people have enough to eat, but that, you know, by moving to healthier diets, we can reduce overweight, obesity, and relate that to premature mortality, but also the level of pollution, the impacts of land use, and links to biodiversity. So, you know, all these things are integrated, all these measures are integrated. Looking at waste and wastewater, the health and climate benefits from improved waste management. Clearly, this affects methane, but also the burning of waste in dumps. We need to get better in terms of the economic analyses. So macroeconomic, you know, sort of linking to sustainable development scenarios, looking at things like jobs. We need to look at income distribution as well, economic structure. We need to understand for transport, you know, sort of if we're looking at transport, it's not just a question of understanding the impact on greenhouse gases and air pollutants, but it's also the strategies related to accidents and related to the health benefits of walking and cycling. You know, these are enormous. So we really need to integrate very broadly to come up with the best solutions for our cities. And then we need to improve our training capacity building. So all of the LEAP material does exist on the website. There's training materials that you can find there. Finally, I'd like to look at from plans to action. So there is another paper on some of the work we did with Nigeria. So looking at the planning process, but also looking into implementation. So this is a meeting where after the production of this national action plan to reduce short-lived climate pollutants, we had these different members. So that's my colleague Chris Malley from SEI, but with people from government, from the Ministry of Environment, from importantly, the Ministry of Budget and National Planning and the Climate Change Director. And so this is then integrated decision making, working out how to implement the measures which they identified in Nigeria. And one of the things we've been doing is to try and systematize the implementation phase. So if you look at one of the measures, which is reduction of methane emissions and open burning of waste at dump sites, then we have this logical framework analysis of different interventions, you know, so training agencies to separate and recycle and compost and landfill, and also, you know, sort of all of this leads to the change in methane emission reductions and reduction of the emissions from landfill fires. And then we can look at, you know, along the value chain of waste, we can find out, well, who needs to be involved. You know, looking at expanding current policies or developing new policies. And one of the things they would like to do in Abuja is to turn the waste pickers, which is informal, into formalized, you know, waste employees. So there are lots of links to development objectives. Finally, then, if you want to find LEAP, then you can access it via this website. You need to request a user and password to fully enable the software. And for some people, there is no charge to non-profit academic government institutions based in the low and lower middle income countries. And then there's a low cost to help pay for its further development. And for high income countries, they need to purchase a standard license. So there's technical support that's available, and there's also training available through SEI, but also other organizations train using LEAP. And you can find all of this on the website. So thank you very much. I think I've talked too much, but hopefully that was useful.
So thank you so much, Dr. Johan, for your nice presentation on LEAP IBC and how it can be used for the mitigation of greenhouse gases and the air pollution. It was very informative presentation, and there's a lot of new things that country can use for the mitigation planning. So may I request the participants to write the questions on the chat box or the Q&A box. I think there is already a question from one of the participants. How to address the uncertainties of LEAP output, that is cost and benefit. Is the output provide range of uncertainties?
So this is one of the issues in integrated assessment, and it's very tricky. What we can do is so what we've done is we have a paper on the emission methodologies, looking, for example, at the standard ways, IPCC ways of looking at the uncertainties around emissions. So that's one thing. The uncertainty around the atmospheric modeling is more difficult to quantify. but there have been a lot of papers written about geoschem, how well it relates to monitoring, etc., etc. That's in the literature. And then you have the uncertainty related to the impact assessment, and then there are standard, ways of looking at the uncertainty in the number of premature deaths, for example. We haven't, propagating those uncertainties along the whole chain is something that is very difficult to do. So, for example, in the UNEP WMO assessment, the only uncertainties were around the temperature response to the changes in the emissions of substances. It wasn't in terms of the emissions. So propagating it is very difficult to give but what we can do is look at those things individually. But at the moment, it's quite tricky to put in ranges and things like that into LEAP. So it tends to be more of an average. So it doesn't tell you the uncertainty ranges as an output. And this is calculations that we've done separately, for example, on the emissions and so forth. It becomes very cumbersome, and there's already a lot. Once you've developed a whole model for a whole country for all sectors, it becomes a big database, and it's possible to look at the uncertainties in the individual components. It's not clear how you would combine them across the whole chain.
Thank you. Any more questions from participants? Please write on the Q&A box or chat box.
One of the things that Dr. Itipol has mentioned, we're working with the Pollution Control Department, applying LEAP at the moment. So looking forward very much to further work there. And then someone says, can we apply LEAP program to estimate emission in ALU sectors? Is that ALU meaning what exactly?
Yeah, there is also in question. Should in using LAP,
LEAP, yes.
should user compare the output of the LEAP with the monitoring data if there is available?
If we apply LEAP at the urban scale, we end up with a population weighted mean. There is some meaning in comparing the mean for a city with monitoring across a city, but it's not one-to-one because it's not looking at the distribution of PM2.5 across the city. So yeah, but to do it for a whole country, very few countries have got monitoring networks covering the whole country to compare with a population weighted mean. So that becomes a bit more difficult. At the urban scale, it becomes more meaningful.
Okay. Any more comments, questions from participants? We still have about 10 to 15 minutes. Okay. Can LEAP IBC apply in a subnational level?
Yes. So, for example, the work we're doing with the Ministry of Environment in Pakistan is developing LEAP for four regions of the country. And you can, so like I was saying also, that the Africa data set that we're developing has 50 countries. So you can divide it, it's flexible. So you can develop data for different regions within the country, and then it will all add up to a national total, for example. Or in the case of the Africa, then all the national totals will add up to a continent-wide total.
Any more comments and questions from participants?
So perhaps if anyone is interested in the training materials, they can go to the website. They can download LEAP to have a play with it, and there's a lot of features which I haven't discussed here. For example, in the development of scenarios, when you develop a scenario, you can give it a name, and then they inherit it down a chain. So you can add. So if you had a transport scenario and a residential scenario, and then the one they can add up to be a total scenario, and then you can quickly compare, sort of analyze the data and see the impact of individual scenarios or all of them together, that sort of thing. But the most important thing is that people then own their own models. It was interesting in Bangladesh when we worked there. We were working with an academic, Professor Tanvir Ahmed at the Bangladesh University of Engineering and Technology. And then we found out that somebody else had been developing an energy model and a greenhouse gas model using LEAP, but totally independently. So then we were able to compare the two and see whether how well we'd done. And luckily, they even though they've been done entirely separately, then they did equate quite well. But there were some things in the other model which were better. So then we were able to upgrade that in this model. So it's easy to sort of send LEAP data sets across the internet as attachments, and then you can open it up and compare it, and so it's used pretty widely. And it's one of the other things which I thought was nice was we launched the LEAP IBC in Nairobi at one of the UNEA meetings, and in Ghana they've been using LEAP. Well, we started working with LEAP when the CCAC was formed in 2013, and so then talking to the Ghana Environment Protection Agency, we said that we were going to sort of develop LEAP to include short-lived climate pollutants. And then Daniel Benefo, who works there, was very happy because he'd been using LEAP for years for his energy planning, and greenhouse gas mitigation planning. And then we'd asked him to come and describe the work in Ghana at the meeting, but he had another appointment at the last minute, so he sent somebody else, Simpson Atieku from the Energy Ministry, and he came along, and we'd never met him before. He'd never met anybody from SEI before, but he'd been using LEAP for 8 years. So I said, that's very interesting. And he said, yeah, well, that's true technology transfer, he said, so it's used pretty widely. And in the case of Ghana, I also was asked to join a meeting virtually from my home, where they had different ministries sat around a table, and they had their LEAP model up on the screen. Obviously, I could hear what was going on. And then, the Ministry of Finance said, oh, we've got some new GDP figures. And so you could hear them typing in the new GDP figures and then pressing the result and seeing what difference that made to their results. So it's really, in that case, it's really integrated within their decision making, and it actually creates collaboration between the different ministries, because they're all putting their own data into it and then using that for their decision making. So the interaction we have with them is just in terms of, when we make changes to LEAP, and we ask them what sort of changes they would like, and all these different benefit calculations they find quite helpful. And they also found very helpful the fact that we can estimate health impacts is really strong, because the decision makers in many cases are more interested in local development benefits than the impact on global temperatures. But showing the linkage between them, it means that it can actually enthuse people for to take more ambitious action on climate change as well, because they're so linked.
There is a question on the clarification. If user has modeling results have you experienced the use of local modeling results in the LEAP, into the LEAP?
You mean atmospheric modeling?
I think so.
We have been, I think at the moment we've developed the benefits calculator so it can take the modeling results from the GeoSchem adjoint model. The adjoint model actually runs backwards, so it is a coefficient between a region, a grid, and a region. So you have emissions for the grids in a country and surrounding countries, and then it tells you what influence that has on the PM 2.5 concentration of the whole country. What we haven't done is to just do the software that will allow us to look at forward model runs, which tend to be sort of region to grid. So, but it's perfectly possible for us to do that. We just haven't done it yet. So most models run forwards rather than backwards. And so, but if those could be gridded, then it's perfectly possible for that to be used. But certainly the emissions can be gridded. So you can output the emissions and then input those to an atmospheric transfer model. So that would be perfectly possible. And you can choose the grid you want, but you then need to sort of develop the proxy data, you know, road networks or population density, that sort of thing. And then you can take the national emission figure and disaggregate it around the country into grids, and then that can be output as into Excel or another data file, and then that can be used to run models. So that's perfectly possible.
Yeah, I have a question from my side.
Right.
I know you are working with the government of Bangladesh and government of Maldives, Pakistan, and I think in Nepal also. Do you have any plan to work with India?
Well, we have got a project with Terry in India with the CCAC. It's not to apply LEAP, but it's to look at the, you know, promote the opportunities related to the integrated approach. So really, it's about the first step in that process of developing the integrated approach. I also sent the paper that we developed for Bangladesh to Mr. Kamyotra, who you know very well, and I think he spread that around. He thought that would be quite useful. So, you know, LEAP has been used a lot in India in the past for various reasons by various people, but I don't think it's been used by the government so far. But you know, there's an opportunity there if they want to use it. Of course, they can, like anybody else.
Because as I am also a focal point for Malay Declaration,
Yes.
so we think we could do something under the Malay Declaration framework, because you are involving in the Malay since beginning. So I'm just because you are already working most of the Malay country members except India.
Yes. Well, in terms of Nepal, we've been working with ISIMOD quite a lot. So,
Okay.
but also the local university there, where there is a in Tribhuvan University, they use LEAP in their undergraduate courses. So, you know, there's lots of people in Nepal who know how to use LEAP because they teach it at the university. And I think there is a women's college, is it in India or Bangladesh, that we're going to use LEAP in their course as well. So it's sometimes it's used in universities. I think that, you know, it's perfectly usable, and I think Mr. Kamyotra thought it might be useful because you could use the same tool in all the states, for example, so that you got something which can be easily combined, or at least is conformable and transparent, and you can see how people have developed it and so forth. So I'm not sure if there is such a tool already being used. I mean, I know some of the other tools like GAINS have been applied in India, but in terms of, you know, the advantage with LEAP is that governments themselves can make their own model. You know, you can have people in government running it, or in a university affiliated with government or with a state or something. So, and then, you know, you got this close relationship between the experts who are developing the scenarios and the decision makers. And for example, in Cote d'Ivoire, where we've been working, we found that by developing the LEAP analysis with them or helping them to develop their own LEAP analysis, it's created more linkages between the air pollution and climate change people in the Ministry of Environment. We've also done some other tools, for example, looking at the carbon sequestration using RED+ methods and just turn it into a spreadsheet. We've been using that with them, and they found that also very useful because they had got consultancy reports about carbon sequestration in forestry, but they didn't understand, because they hadn't undertaken the analysis themselves, they didn't understand what assumptions had been made, but they could see it in this spreadsheet. And so that's the importance, I think, of getting these analyses done by people on the ground, because if they are confident about the results, or at least they understand, you know, the potential uncertainties and what assumptions have been made, they are much more confident in their advice to policymakers. So I just think that we really need to build the capacity on the ground generally for these issues.
Okay, I think there is no more question from the participants. So thank you so much, Dr. Johan, for your nice presentation on LEAP IBC. And if anyone have any more questions to Dr. Johan, just let me know or just email me. I will pass the questions to him and he will respond you later. So thank you, sir, for joining and for your great contribution to workshop.
Thank you very much, and congratulations on a very interesting workshop.
Thank you so much. So now let's move to the next presentation. That is presentation number 4 of this air pollution mitigation policy module. And this presentation is on clean air measures for Asia Pacific region by Miss Maria Caterina Padu. She is very popularly known as K. From the United Nations Environmental Program, Asia Pacific Region Office, Bangkok, Thailand. So Ms. K is an associate program officer at the UNEP Asia Pacific Regional Office, Bangkok. She is a coordinator of the Asia Pacific Clean Air Partnership, that is APCAP. A regional partnership working to achieve measurable reduction in air pollution emissions in Asia Pacific region. She has over 10 years of experience on working on air quality issues in the region. Prior to joining the UNEP, Ms. K was working with the Clean Air Asia, helping in developing air quality action plans and assessing the status of air pollution in the region. Ms. K, the floor is yours.
Thanks, Norma, and good afternoon, everyone. Very nice to see you all, and happy to join this workshop. Of course, on behalf of the United Nations Environment Program, I wish to express my thanks to our colleagues at RRC.AP for this opportunity to partner and also to speak today at this capacity development program on air quality management and emissions reduction of PM 2.5 for Asian countries. There we go. So for this afternoon's presentation, I would like to share with you some of our work in terms of the 25 clean air measures and some of the recent findings of UNEP's publication and assessments that we released in the last couple of weeks. A lot of these, of course, we shared as part of the commemoration of the International Day of Clean Air for Blue Skies last week on 7th of September. So this might be a very familiar slide to everyone here. Of course, we know that air pollution is now at a critical state, and it still continues to be the world's single largest environmental health risk, as indicated by the World Health Organization. We know that the numbers paint a very worrying picture, with around 92% of the people that are living here in Asia Pacific are exposed to levels of poor air quality. We also know that without very strong policy interventions, exposure to fine particulate matter or PM2.5 could be potentially increasing by 50% by 2030. From UNEP, as the UN agency mandated to address environmental issues, we have seen that together with climate change and also with biodiversity loss, pollution is now one of the three key environmental crises that is affecting our planet today. And this is really something that we really need to address very strongly. Air pollution affects everyone, but the impact on the most vulnerable groups are very, very worrying. This includes children, women, elderly, and those people that are already living in poverty. As you may have seen in the earlier slide, in 2019 alone, it was estimated, I think, by the State of Global Air in 2020, about 216,000 newborn deaths were associated with air pollution across Asia and the Pacific. It also affects a child's development, learning, and overall well-being. And there's also increasing evidence of the impact of air pollution on a child's cognitive development, which emphasizes effects that they will feel throughout their entire lifetime. So not only when they are children. And of course, as we are still experiencing this pandemic, we have already seen some early studies that suggest that air pollution might be putting people further at risk during this COVID-19 pandemic. And this gives us yet another reason to urgently address air pollution. So from UN Environment Program in 2014, UNEP was called upon by member states at the first ever United Nations Environment Assembly in Nairobi to facilitate immediate and coordinated action to address air pollution, and also to prepare a regional assessment on air quality to identify solutions that need to be taken up to improve air quality. So as a response to this mandate, the UN Environment Program Asia Pacific Office in Bangkok launched the Asia Pacific Clean Air Partnership APCAP in 2015. This partnership was really set up to help enhance some of the synergies among various air pollution initiatives that are all already working within the region, and also to promote science policy dialogue. Soon after that, with the support of the government of Japan, in partnership with the Climate and Clean Air Coalition, and also with many partners that have actually joined us in this week's event, APCAP coordinated and assessed a regional assessment of the latest science and evidence to identify successful air quality management actions for the region. This was even further emphasized during the United Nations Environment Assembly in 2017 with the adoption of another resolutions further strengthening the need to urgently address air pollution and the need for such regional assessments to identify actions that the regions need to take to improve air quality at the local level. What we have seen so far and very positive is that as a product of this review and assessment is that we know the solutions to be able to beat air pollution. One of the products of this overall partnership is this report, the Air Pollution in Asia and the Pacific Science-Based Solutions, which we launched in 2018 at the World Health Organization's first global conference on air pollution and health. And this work really identifies 25 policy and technology measures that will deliver benefits across 5 key sectors that are the main sources of primarily PM2.5 and also considering ozone in our region. And based on the analysis, if we fully implement these measures, plus the existing commitments and policies that are already in place, we would be able to see 1 billion people that are living in Asia breathe air that are at least within the World Health Organization guidelines for public health protection by 2030. So what are these 25 clear measures? Some of you might already be quite familiar with them, but maybe just to briefly summarize what these measures are. So we have categorized them into three clusters. The first one is on conventional emission controls that are focusing on emissions that lead to the formation of primary PM2.5. So this really includes strengthened emission standards and controls on vehicles, power plants, and large and small scale industry. The next category is, we call them next stage air quality measures. Next stage air quality measures, which reduce emissions that lead to the formation of secondary PM2.5 and are not yet major components of clean air policies in many parts of the region. So this really includes reducing burning of agricultural and municipal waste, preventing forest and peatland fires, and also proper management of livestock manure. And we have heard earlier from Johan's presentation, of course, the increasing relevance of addressing emissions coming from the agricultural sector for air pollution and climate. And then the third cluster of these measures, we call them development priority measures, because these are the measures that contribute to development priority goals of countries and cities, but also provide benefits for air quality. So this includes providing clean energy for households, improving public transport, promoting the use of electric vehicles, and using renewable energy for electricity generation. So I wanted to actually show you a short video that briefly goes through each of the 25.
Ms. K, we cannot hear the voice of the video. Hello, we cannot hear you.
Okay, I'm not sure what happened, but yeah, maybe I can just share this video later.
Yeah, if you have separate video file, you can just share it.
Yeah, I think we can just share it later. And if you can still hear me and not hear the those out, it tries the background sound going through the 25 clear measures.
Ms. K, could you please optimize your output? Can you come here?
Hi,
Yeah, in
Burma.
order to play video, we have to select sharing option with optimize motion and video. So can you stop sharing?
Hold on, stop sharing.
Yeah, stop sharing, then go to share,
Okay.
go to share
Yeah.
once again. Then in the
Okay.
default is automatic.
Yes,
So
I
you
have
to
automatically
select
optimized for motion and video.
exactly.
Yes, yes.
Okay, perfect. Thanks.
Then you can play your video. Yes.
Okay, let's give. Sorry. Sorry. Sound that you can hear it now. you. I hope it was clear, but it was just I just wanted to share with you because it's a lot of measures. Just very briefly what those are, and I'm sure many of them are very familiar to most of you, and a lot of them are already being implemented. So it has been a few years since we have launched the report, and it's always good to see, you know, where are we now since we have seen the 25 Clean Air Measures report. And we are very pleased to say that since then, we have seen that many countries are taking action to reduce air pollution. This is actually a slide from a new publication that UNEP launched on September 7th, where we reviewed policy actions of member states to improve air quality based on the mandate by the United Nations Environment Assembly Resolution 3-8 on preventing and reducing air pollution to improve air quality globally. The figure that I'm showing, this is for, I think, the global assessment, but we also have a specific analysis for Asia Pacific region that is forthcoming. But I do want to share with you some of the findings from this work. The key one that I want to share is that overall progress, that there is overall progress in undertaking key actions that can significantly improve air quality. For example, many countries have incentives or policies in place to promote cleaner production, energy efficiency, and pollution abatement for industries. Here in the Asia Pacific region, there has been significant increase in terms of access to clean cooking, and this has drastically reduced exposure and attributable deaths in the region. Based on some studies, more than 300 million people have actually benefited from clean cooking and heating programs that have been adopted in 28 of the 41 countries here in Asia Pacific region since 2016. Within the transport sector, there has also been quite good progress in adopting conventional measures to reduce vehicle emissions. For example, 23 of the 41 countries in Asia Pacific region now have vehicle emission standards in place as of last year. Of course, there are differences in terms of the Euro standards are being implemented, but we do see that there is action to take up more stringent emission standards. We have also seen that many countries have adopted or are planning to adopt national and subnational laws and strategies to achieve their overall air quality goals. So this also includes, of course, India's National Clean Air Program in 2019, which aims to reduce PM2.5, I think by 20 to 30% by 2024 compared to the 2017 levels. And of course, I think our next speaker will be able to elaborate on this further. There are other countries that have done that, adopted and updated their strategies or action plans to address air pollution, including China. We're also working with Cambodia currently to hopefully launch their first national clean air plan. Japan, Maldives, Mongolia, Vietnam, and among others. So it is, I think, a very, very, very positive sign. And a lot of these actions, of course, have had a positive impact on air quality. And this is what we would like to see. We would like to see action that actually lead to improvements in air quality levels. The State of the Global Air 2020 report estimates that the population-weighted PM2.5 levels in half of the countries in our region have actually been at least reduced from 2015 to 2019. I don't have the figures in my slide, but I think Johan also showed some of those data earlier, but a lot of them are available online in the State of Global Air report. This was actually also observed in the 74 key cities in China that were initially identified in 2013 for stronger air pollution control when the State Council announced their war on air pollution and adopted their action plan for air pollution prevention and control in China for 2013 to 2017. And I just wanted to share these with you because we think that these are very powerful numbers showing that strong action can lead to significant benefits for air quality, health, and is also presenting value for money in terms of the investment that was provided. During the implementation of the 5-year action plan, China maintained overall economic growth while reducing emissions from almost all of the criteria pollutants and improving overall air quality in many of the Chinese cities that have been identified. So you see here some of the statistics that some of partners have analyzed. PM2.5 levels decreased by 34.7%, for example. And this has also had positive impacts on health, with an estimated close to 50,000 less deaths in 2017 compared to 2013. And of course, I think from a policymaker point of view, health impact's good. Attaching a dollar cost, of course, is always quite useful as well. And we see that the analysis show that the benefits greatly outweigh the cost. There has been a study estimating the health benefit of air quality improvement was 1.5 times the cost of the policy implementation of the 5-year action plan. So it really shows that the investment to air pollution was worth it. So even if there has been so much has been done, our work does not stop here. There is still more that we need to do together. There was actually a new research that came out, I think the other day, by the Health Effects Institute that found that there is really no safe level in terms of air pollution for health. And there is association between exposure to even very low levels of air pollution, and I think they did this in 11 European countries, and adverse health outcomes. So we still need to continue our efforts to reduce and improve air quality levels in our areas. So while progress can be observed across different sectors in adopting key policies and actions that are known to reduce air pollution, there are still significant gaps that remain. This is really especially true when it comes to enabling policy frameworks to accompany sectoral measures. So including air quality standards, air quality management capacity, and air quality monitoring. This is what I want to just focus on in this slide. 1 in 3 countries in the world currently lack legally mandated standards for outdoor air quality. And unfortunately, at least 31% of countries with existing powers to introduce standards have not used them yet. And this is based on another assessment, first ever that UNEP has done, of air quality laws and regulations that we also launched last week. While there has also been, promising developments in monitoring systems with Earth observation, increasing popularity of low-cost sensors, there is still very significant data and capacity challenges. And we know that many countries and cities continue to struggle to establish and maintain a sustainable air quality monitoring network. Some countries that have continuous monitoring at multiple sites don't have enough monitors to adequately characterize the exposure based on the size of the population. Based on the analysis that we've also done, 60% of the countries accounting for 18% of the global population have no routine annual ground-based monitoring of PM2.5 at all. And this is, of course, quite worrying. Because even if monitoring itself, of course, we know does not reduce the emission, the data and the information that we gather from monitoring networks is very important because this serves to build the knowledge about the scope of the problem and help represent even as a catalyst for action, as we have seen in some cities in Asia. Within our region, we know that we need to also strengthen intervention in specific sectors such as waste management, agriculture, and phasing down of coal. I would like to just highlight the importance of addressing open burning from municipal solid waste and also from agricultural crop residue, which many of us here know is a very important contributor to air pollution here in our region. Open burning, unfortunately, is still a widespread practice, even though it is increasingly being regulated. From our analysis, there's still limited evidence in terms of incentives to promote sustainable agricultural practices, and this is something that needs to be further strengthened. Agriculture, of course, is becoming increasingly an important source of air pollution, with ammonia and methane emissions also contributing to PM2.5 in ozone. And as especially for us here, I think in Southeast Asia, crop residue burning leads to increased PM2.5 levels in many parts of our region, especially on a seasonal basis. So it needs to be further addressed. This is something, of course, that we recognize, and we have actually started to work with a few partners here in Thailand and also in Vietnam to try to understand the issue, discuss with some of the farming communities and also with private sector in terms of what kind of solutions are in place. And I just wanted to share with you some of the reasons that we have heard through our partners in terms of the reasons why, for example, farming communities continue to burn. Most farmers consider burning as a viable option for cost saving, reducing labor costs, minimizing the duration of the cultivation, enabling for more efficient harvest and transportation, sometimes saying it aids in pest control, removing weeds, and facilitating tillage. Despite the introduction of farming machinery as an alternative to burning, these are usually found to be too costly for the farmers to use, utilize, and maintain. And of course, these are some of the issues that we would need to address to be able to really address open burning in our region. We also need the investment that matches the scale of the problem. And unfortunately, and this is based on a new report that was launched by the Clean Air Fund last week, less than 1% of the total official development and foundation funding is spent on air pollution projects. And this is despite the fact that air quality related deaths in countries that are receiving aid has increased by 153% in the past 30 years. And unfortunately, some of the official development funders have actually invested more in fossil fuel related projects than in air quality projects in 2019 and 2020. And this is something we're hoping to be able to revise in terms of a trend. Of course, yeah, so we still have a lot to work on, but we must not lose hope. We can turn a tide, so we can reverse these trends, and we can I think we can still make a change. We have shown that how we can respond amid very difficult and challenging times, even now during this pandemic. It has compelled a lot of nations to really rethink their economies and national priorities. And we have seen that a lot have also realized the importance of a healthy environment and how it is central to healthy people. As a result, as many of us may have seen, many countries have already pledged to build back better and hopefully invest in a green transition and also commit to overall carbon neutrality. I do want to share with you one milestone that we have reached, I think, together as a community. Just 2 weeks ago, we reached a major milestone with the official end of use of leaded petrol globally. And this was actually after almost a 2-decade campaign by the UNEP-led Global Partnership for Clean Fuels and Vehicles. I think some of the other organizations that are participating in our workshop are also part of this PCFV to help the world abandon leaded fuel. And we are pleased to say that this was, of course, a very long road, but it was through a combination of public and private partnership, on the ground technical support, and international cooperation that was really the formula to the success. And we have seen that this has actually very important benefits for people's health, with some studies estimating that for every year, the leaded fuel bans have saved more than 1.2 million lives while also helping the global economy avoid 2.4 US dollar trillion cost in terms of healthcare and other associated costs. And I just wanted to reiterate some of the words of the UN Secretary General, Antonio Gutierrez, when he said that this achievement really shows what we can accomplish when we work together across countries and sectors for the common good. And this is something we hope to replicate and continue in our work to beat air pollution. I want to take now some time to just share some of the opportunities that we see to advance the implementation of clean air solutions. So the first one is related to COVID-19 and how we can build back better. I'm sure many of you have seen in the early months of 2020, the implementation of restrictions to curb the spread of COVID-19 has resulted in some short-term reduction in certain air pollutants. And we see this as a potential opportunity and for countries to really consider and prioritize transformative measures, hopefully within their recovery plans, because we have seen that transformative change is now possible, I think, with what we have seen with the pandemic. The analysis that UNEP has done shows that a green low carbon recovery could potentially reduce as much as 25% of emissions by 2030, support socioeconomic recovery by creating close to 200 million jobs, and also 3.6 trillion US dollars of additional revenue also by 2030. Unfortunately, we're still a long way to go. So far, only 18% of the spending was considered green, and this was really mostly accounted for by a small group of high-income countries. So at least from our region, we still need to strengthen engagement with member states to be able to advance greener recovery plans. We're actually working with partners to assess some of the linkages between air quality and COVID-19 related impact currently now in 3 cities, in Jakarta, in Colombo, and also in Kawasaki, in Japan. Jakarta, together with Dr. Didin and Professor Mohoyatun, and with Kawasaki, together with our colleagues at IJAS, who have both, I think, spoken in the workshop this week. And we really wanted to see some of the opportunities that exist to be able to sustain or at least bring back some of the improvements that we have seen last year, and some of the potential benefits to air quality and health with the measures that the governments are implementing as part of recovery plan, and what kind of recommendations we can put forward for their consideration. Oops, sorry. Okay. I won't speak on this too much anymore because I think our last couple of speakers have highlighted this quite strongly. Of course, clean air and climate action is a very strong opportunity for us to improve our air quality and, of course, lead to a stable climate. And we have seen some of the recent strong pledges for a healthy, resilient, zero carbon recovery ahead of COP26 through to the Race to Zero campaign could also potentially bring significant benefits for air quality and plus other sectors. And as many of our speakers have already highlighted, air quality and climate change are very much related. So we're hoping to be able to engage more partners to help us in this regard. Maybe just one aspect that I wanted to mention, I think as Johan already mentioned, we are working with the capital metropolitan area, or Seoul, Incheon, and Gyeonggi in the Republic of Korea to assess their efforts to address air pollution, to improve air pollution and improve their further policy actions and identify some of the good practices that could be done to inspire other cities to address air pollution. And we are trying to see if we can also incorporate some of the benefits for climate that their air pollution strategies have contributed to. The next opportunity that I wanted to mention was using health as an entry point. Of course, I think health touches upon everyone very strongly. Within the region, we have this Asia Pacific Regional Forum on Health and Environment, which is currently being chaired by the government of Indonesia through the Ministry of Health and the Ministry of Environment and Forest. And this really is quite an important forum, bringing together both environment and health ministries together to address cross-sectoral issues, including air quality, climate, and health. Because we know that just working with one ministry is not sufficient to be able to address this interconnected challenge. Among all of these vulnerable groups that we're working with, of course, we recognize that children are those that are at highest risk from the impacts of air pollution. We're actually collaborating with the UNICEF East Asia Pacific Regional Office here in Bangkok on child-centered clean air solutions and how these could be used to help advance children's right to a healthy, sustainable environment in Asia Pacific. So we have developed a guide identifying 20 child-centered clean air solutions, and this really builds upon the 25 clean air measures that have been developed by UNEP, CCAC, and many partners. But one of the additional aspects that we have tried to look here is some of the benefits of these measures for children's health, and what are the additional considerations to be able to reduce children's exposure to air pollution and reduce their impacts on health, specifically in certain types of microenvironments where they may be at high risk of exposure. So for example, in schools and in homes and in when they travel. We also wanted to emphasize the importance of youth engagement and participation and how they can support in implementing and advocating for child-centered clean air solutions. One of the other aspects and opportunities that I wanted to highlight is in engagement of the private sector. And of course, we need partnerships with the private sector to support and facilitate cleaner action. One of the public-private partnerships that UNEP has supported is the Sustainable Rice Platform, SRP, which is the first voluntary standard for rice sustainability. And just wanted to highlight this. This also contributes to 2 of the 25 clean air measures relating to promotion of more efficient rice production practices and also better management of agricultural crop residues. Of course, the Sustainable Rice Platform looks at overall process in terms of rice, not only just in terms of open burning, but I think this is one of the very nice examples that we wanted to share. One of the measured changes or benefits that we have seen from the adoption of the sustainable rice cultivation practices was an estimated 10% increase in the farmer income from improvement in yield and the premium that is usually attached to sustainably produced rice, plus the reduced input yield such as water or fertilizer for cultivation of rice. And they also work with many private sector partners in terms of establishing the standard on sustainable rice cultivation, including Olam, Mars Food, Nestle, among others. One other example of public and private partnership that I also wanted to highlight in terms of the area of air quality monitoring is UNEP's partnership with IQ Air and UN Habitat, which really focuses on developing real-time air quality data bank. And I think they just launched a data bank, an updated version of the data bank last week during the International Day of Clean Air for Blue Skies, and trying to integrate some of the real-time air quality data from different initiatives that are run by citizens, communities, governments, and the private sector. I think that should also be available online in the UNEP website. Finally, I did want to highlight the importance of strengthened cooperation on clean air. This is something we, I think, repeat many times, but of course, air pollution is a shared responsibility, which we know we need to work together to be able to address it, because by its nature, air pollution transcends all of the boundaries that we attach to it. And emissions itself can come from multiple sources, could be from within the city, outside the city, or even outside our country. So we really need to have an integrated approach and collaborate with many partners to be able to successfully improve air quality within our vicinities. We're very happy to see that the UN General Assembly has actually designated the 7th of September as the International Day of Clean Air for Blue Skies. And this is really an opportunity for us to facilitate international cooperation in air pollution. So I won't highlight this thing too much, but I hope that we can continue to work with the many partners that are here as UNEP is facilitating the commemoration of this day every year, together with many partners, including CCAC. Within the region, and just to share with you, in case you weren't able to join us last week, one of the ways that we have commemorated the International Day of Clean Air for Blue Skies was during the 3rd Asia Pacific Clean Air Partnership Joint Forum that was hosted by the Ministry of Environment of Japan, where we had very interesting discussions under the theme of building back better for healthy air and healthy planet. If you're interested, I think the session recordings are available now in our virtual venue and will be updated soon in our event website, cleanairweek.org. And I invite you to watch in case you're interested, and happy to follow up on some of the interesting discussions that we have seen during the forum and also during the side events that we have organized last week. Okay, so just in terms of a summary, so as we know, just to repeat the messages, air pollution is really at a critical stage, and we have seen that while there has been good progress, we have achieved good progress in the last couple of years to reduce emissions, take up very strong policy action, and hopefully decouple emissions from economic growth. There still is a lot that needs to be done to be able to protect human health and also help us in our overall recovery plans. Just wanted to highlight a few key messages for you hopefully to take on. I didn't highlight this, I think, so much in our in this presentation, but this is something that we have been discussing with many partners here. Most of us in the region live in cities, so the focus has of many of the air pollution prevention policies have been in cities. But of course, there has been increasing analysis on the importance of working with rural agencies, not only urban agencies, to be able to address air pollution. So we really need to have national, urban, and rural authorities with responsibilities for activities resulting in emissions to collaborate. And this is something we are advocating and hoping to be able to push forward for a coordinated, multi-pollutant, multi-sector approach within our cities, together with our neighboring provinces, for example, but also even taking it up at an international scale. We also wanted to recognize the importance of scientific assessments, including source apportionment, modeling, integrated assessments, as a very important tool to be able to help us understand PM 2.5 sources and their contribution to help us really develop well-informed policies. And this was something that was very strong when we developed the regional assessment for the 25 clean air solutions. Yes, and of course, I think from UNEP, we will continue to support efforts to accelerate urgent action that is needed and support these 25 recommended clean air measures together with our partners. We look forward to working together to beat air pollution for healthy air and healthy planet. And maybe as a final word, just to echo some of because I really like this statement from our Executive Director, Ingrid Anderson, when she said that air pollution has no place in the future that we are all working towards, and we cannot realize the 2030 agenda without clean air. So we're hoping to work together with our partners here, and I hope that this was also informative for you. Thank you for your kind attention.
Thank you, Ms. K, for your nice presentation on the clean air measures taken under the APCAF framework by the countries. So it was a very nice presentation and very informative, and a lot of new information you added in the presentation. Now, may I request the participants to write your questions on chat box or Q&A box so that the Ms. K can answer those questions. So participants, could you please write your questions on the chat box or Q&A box?
So maybe just to share with you the reports that I mentioned, the actions on air quality, the global summary is available online. The regional version of that for Asia Pacific is forthcoming. And this, the first ever assessment of air quality laws and legislation, which really focuses on analysis of the air quality standards plus the monitoring interventions, is also available online. And this is, as you might have seen, we're also very much awaiting the release of the new World Health Organization updated air quality guidelines from WHO, which I think is expected on the 22nd of September. So it would be nice to see, I think, how what this could potentially mean for air quality standards and air quality policies here in Asia Pacific region, as of course many of our governments look to the guidelines that the World Health Organization provide as a basis for setting up and further improving their air quality standards.
Thank you, Ms. K, for more elaboration about the publication. Participants, if you have some questions, please write on the chat box or Q&A box. There is a question. Is there any ongoing project or assessment for the Asia Pacific that initiated by the UNEP?
For Asia Pacific, could you, is it a general assessment or what is the?
I do not know, but the question is like, is there any ongoing project or assessment for the Asia Pacific that initiated by the UNEP?
So for us, at least within the regional office, the latest assessment that we have, this analysis that we are doing is in terms of the actions in air quality. So this refers to the different policies that member states, so the 41 member states here in Asia Pacific region are implementing in terms of air quality. So it's more looking at policy interventions that governments are taking to address air pollution. If this is specific to, of course, air quality. At the national, there are quite a few in terms of a national level. As I mentioned, we're doing some work in Korea together with SEI, in Cambodia, and in a few subnational assessments in Jakarta, Colombo, and in Kawasaki. So these are the ones that from the Asia Pacific Cleaner Partnership we are advancing.
Okay, thank you. Let me see if there is some more questions. I don't see any questions. So thank you so much, Ms. K, for your nice presentation.
Thank you.
Now let's move to the next presentation. The fifth and the last presentation of the air pollution mitigation policies module is on National Clean Air Program of India by Mr. Sandeep from the Ministry of Environment, Ministry of Environment, Forest and Climate Change, the Government of India. Mr. Sandeep is a director at the Ministry of Environment and Forest and Climate Change, Government of India. He is also a project director for the Society of Integrated Coastal Management, that is SICOM. He has more than 25 years of experience in environmental management, prevention and control of industrial and urban pollution, enforcement and monitoring, framing environmental regulatory policies, programs, and emission standard, appraisal of projects for environmental clearance, river basin rejuvenation program, and wastewater treatment technologies. He is a graduate in civil engineering and master in environmental engineering. His technical contributions are well acknowledged in many of the CPCB research-based publications, including framing guidelines and protocols on pollution and prevention, abatement, and control measures. Presently, he is coordinating the National Clean Air Program of India. Mr. Sandeep, the floor is yours.
Thank you, Dr. Verma. Am I audible?
Yeah, you're.
Yeah. Thank you, Dr. Verma. And I feel a gratitude to be at this forum, especially with the initiative taken by RRC.AP for the capacity development on a critical issue like air quality management, especially with respect to urban Asian countries where we do need a lot of exchange of knowledge and ideas. I must thank you for giving us opportunity to share our experience, and that may help many of the participants, especially the neighboring countries in Southeast Asia, who lives more or less in the similar conditions with the same population behavior and everything, to deal with and to take some learning out of our experience, what we share as of what we are doing under National Clean Air Program. Now, having said that, since we will be discussing, I've gone through the various topics which has been discussed over last 3 days, and all the experts has talked about many of the very critical issue when we talk air pollution management per se. I will be concentrating on what we are doing with the program to contain urban air pollution and how we are moving, what we did and what we are doing, what are the gaps, what are the mechanisms we are taking, what are the strategies. On these things, I will try to highlight the efforts we are putting in India to contain or to improve the air quality that way. So having said that, I will prefer to have some sharing of slides. Just a minute. I think slides are audible now, visible. Dr. Verma, can you confirm me?
Yes, we can see the slides.
Okay, so thank you. So now this is a program we launched in 2019 after going through the water air quality assessment of various cities. Just to give you a background, we run almost 1,000 air quality monitoring stations from the government side, and there are similar or even more from the private or the industrial sector, which do the monitoring of ambient environment air quality. And based on those data, we have classified, we have categorized based on certain indexation, and urban cities are being compared with the national ambient standard, and some industrial areas are also compared, and then these two have been classified like being taken separately. So when we talk about national clean air program, it is more urban centric, although it looks after the causes arising out of industrial sector, but the effect we are looking to address is on urban centric environment. For industrial area, the source containment, source control, those things we take it in a separate program, which is critical environmental pollution index program. So we will not be discussing much on that at all. We will be concentrating on urban air pollution. Now, as you say in the slide, you can see that the causes what we want to highlight is there. When we say the background of air quality and geographical and seasonal variation, these three are very important because India is a very vast country. It has a very different meteorological and climatic condition across its length and width. We have huge Himalayan range, then we have Indo-Gangetic plain, then we have Deccan plateau, and then at the bottom we have sea influenced area. There are islands, so we have desert area. So if we see, we have all variation which is possible, and having a uniform yardstick for such variable meteorological conditions or climatic condition, it becomes very difficult and challenging to have uniform approach for across India. Now, as we all are aware that air pollution is like there has been discussion, there will be session on that. The meteorological conditions and the climatic conditions, basically the seasonal variations play a major role, even the sources are uniform as far as the consequences concerned. So that gives bigger challenge. Then there are certain issues which is natural in nature, natural occurring, like when we, and which is again dependent upon the type of lithology and the geography you are in, how best it is covered by greenery, or how barren the lands are, what is the potential of natural wind erosion and contribution to air pollution. These things create huge challenge. So when we look into these things, we have seen that geographical and seasonal variations are very important as far as having a management plan for improvement of air quality. Indo-Gangetic plain is itself a challenge, which is one of the largest basin, having almost 40% of our population residing in this basin, Ganga basin. And the length and breadth is so big that when we talk about early basin, we can divide the basin into three phases. One phase is having temperature, things are much below. The middle one is like it goes between 22 to 32 or 35, just to give you an idea. And the latter, the third portion, which goes from 35 to 42 or something like that. So these are the temperature variations. Similarly, the mixing height changes, the wind speed changes, wind direction changes. So this is, and then it forms a airshed which has huge amount of emission sources. So that part, and maximum urban agglomerations with high density like Delhi, Calcutta, Kanpur, Lucknow, these are all million plus cities. They all lie within this Indo-Gangetic. So if we see pollution weighted impact, Indo-Gangetic has maximum that way. There are multi-sectoral contributions which also create challenges, like there are point source from industrial sector, then we have line source, especially in urban area, from vehicular pollution, we all know this, and then there are uh, what we say is municipal solid waste management, poor way of municipal solid waste management, where things are improving, open burning, agriculture stubble burnings, these things also complicate the issue. So this is another micro level analysis which is required to be taken up. And then we talk about transboundary and airshed contribution. What exactly the airshed contributes of its own, and how much it is coming from outside the airshed, which contributes to the air quality of that area. So these are the governing factor when we talk about how to go ahead on strategy planning and do scientific studies on that. We have put in some regulatory mechanism and management system in place. The first regulatory provision was as for air pollution is as old as in 1905, but 1905. But coming to this post 1981 with Air Prevention and Control of Pollution Act, it provided huge to the government on regulatory provisions. This act also provide some responsibility on the institution created for control of pollution, the various stakeholders, whether they are the source emitter, emitting sources, or the management part. So this act provides a lot of tooth for containment or improvement of air quality. Similarly, we have a Environmental Protection Act wherein we can make various rules to address specific causes. Like as we go ahead in the slides, we will talk about that, like municipal solid waste management or construction and demolition waste. For these things, hazardous waste, we have come out with rules which governs their management practices. It also gives responsibility on the stakeholders, their role and responsibilities are defined, and their accountabilities are fixed. We have certain authorities and commissions which are for sensitive and problematic area identified to deal with in a comprehensive way with better coordination in that small geographical or administrative boundary. Like recently we have one commission set up for National Capital Region of Delhi, which on regular basis for last 5-7 years has witnessed acute winter air quality. And that has to be taken up in a comprehensive way. So a commission has been constituted and they are working on it. So in nutshell, where the problems are huge, they require a dedicated team. Sensitivity is very high. So commission and authorities has been put in place. Then we have defined the National Ambient Standard, including the sources emission based standards, like what will be the emission norms for power plant, what will be the emission norms for vehicular, like we are running right now on Bharat Stage 6, which is equivalent to Euro 6. We took a bold decision, and from Euro 4 to Euro 6 directly we switched over what we say leapfrogging, without giving much of the time to the auto sector, and we were able to do a good EU6 compatible fuel also available by investing 1.6 lakh crore, almost 2 lakh crores, if I can say so, for just improvement of fuel quality. We do some environmental clearance, which is mandatory for certain 32 given sectors, which has a high risk, high potential of air pollution, water pollution, or environmental issues. So they have to go mandatory. They have to take prior environmental clearance before initiating any work on field, so that they are assessed for their environmental soundness, what we can accept, what are the management plan they have to incorporate, those things are there. Similarly, for monitoring purpose, we have now started very aggressively on real-time basis, whether it is source or ambient air quality. So almost, if I may say so, more than 3,000 industries which are having high potential of emission, those are all connected on real-time basis for their emission. Similarly, for major cities, we have derived and all ambient air are being captured, quality is being captured on daily basis with a frequency or 15 minutes data are being captured. We have taken a lot of bold decisions as far as shifting of polluting industries are concerned from the urban areas. And to give you a idea, Delhi does not have any highly polluting industry within its territorial boundary. All highly polluting industries has been shifted out of that, and whatever sources are there, they have been asked to change over to a cleaner fuel. Now we have central level and national level regulatory bodies, authorities will look after at provision at what we say state level, that is provincial level, and at national level. National level is basically for coordination and providing knowledge base and national policy to maintain uniformity across the country. And the provincial state pollution control boards take care of specific site-specific requirements, and they have the power to modulate, make it more stringent, the requirements as far as environmental norms are concerned. Then we have, for urban program, we have rope in the real implementing agencies, the industrial association, academia, and the urban local bodies. They are the primary custodian of everything. They will be implementing it, and we want to thrust upon them because they are responsible for taking up overall sanitation and environmental condition for improvement at urban local body area. And they do all basic work, development of infrastructure. So they are the primary stakeholder in this. Now, these are the standard, what we say is the National Ambient Air Quality Standard. We have two types of standard, that is one is annual and one is daily, 24-hour. If you see, there are two type of classification. One is eco-sensitive area, which is notified and based on certain criteria for that, and other is another other than eco-sensitive area. So whether it is rural area, urban area, all will be having same as it is in column 5, sorry. Column 4 is applicable except for eco-sensitive area. The parameters what is there, this was notified in 2009, and it is a evolving process based on various studies and criteria how to divide on that. And now these pollutants which are there, we are focusing on PM10, PM 2.5, then SO2, that is sulfur dioxide, oxide of nitrogen, ozone. Now ozone is hourly basis and 8-hourly basis. Lead was there when we started with this. Now we are thinking of whether we should contain it or not, because most of our fuel, which was the major source of lead in ambient air for last 7 to 8 years, we don't have any almost negligible fuel, lead in the fuel. So that we are looking at whether we should retain it or continue with that or not. Similarly, CO, ammonia, benzene, benzoalphaparin, arsenic, and nickel. These are the 12 parameters we monitor. Based on that, we decide on this. And then there are certain methodologies which has been defined, and how many numbers will be taken to have a representation as an annual value. Like these things are there. Now, another index we came out was basically to have, when we talk about in numbers, people are not, general people per se are not getting sensitized, because it becomes a more sort of a more scientific numbers and then interpretation and those things. So we decided, and in 4 years back, we came out with air quality index. Now these index are based on basically 8 parameters. We take up any 3 parameters which are critical on a particular day. The data are taken for consideration is for 24-hour data. Basically, these index are derived from the continuous ambient air quality monitoring station. That is a real-time data what we capture in 24 hours. Now, the factor is the index is based on 4-5 criteria. Of that, 2 is very important. What is the exceedance factor of a particular pollutant like PM10, how much it exceeds with respect to the national ambient standard? And that exceedance factor has been again indexified with some corroborative scientific study carried out on health and concentration. And that we have tried to work out in an index form and come out that a PM10. So what happens basically is, out of this 8 parameters, we take up this 8 parameters when we take, which has the highest exceeding factor. Those 3 are taken, and then out of that 3, a empirical formula has been devised. And based on that, we come out with numbers which can go start from 0 to 500. And then if it is 0 to 50, it is said to be a good quality. 51 to 100 is satisfactory. 100 to 200 is moderately polluted, because again we look at it, what are the exceedance factor of various parameters and which is the critical parameter for a particular day. Then thereafter 200 and above is poor, very poor, and severe. Once it is severe, then we have now devised a mechanism that what are the corrective measures corresponding has to be done. What we call it as graded response action plan. Like when the city air quality goes to poor or very poor or severe, what are the activities has to be regulated, closed, or certain constraint has to be put in, like various options are given, and those things are taken care at the field. So based on this index, we have derived a graded action plan, and those action plans are being put in force. Like the moment it goes to very poor or severe, we asked all the industry in the peripheral area within that region who comes under that airshed that please stop your production or switch over to cleaner fuel or to higher percentage, or we ask them to close down till the area, till the condition is severe. So that way we regulate various activities, and these are all done in consultation with all the stakeholders, including industries. So they also realize this and they are happy to contribute towards this. Now, just to give you a profile, when we did a water air quality analysis of 2015 to 19, we saw that what is the average this 4-5 year particulate matter concentration and how the cities can be mapped. So 17 cities were having more than 200 on annual average for PM10. Similarly, 61 to 100 was 143, whereas the standard is 60. So if you see, so from 143 and 17 cumulatively, there are various cities which are cause of concern, and these were located, and then we started working on these cities, how to move ahead and see what measures can be taken up. Similarly, when we do a city profile with respect to air quality index, we found similar pattern, that number of cities having 26 to 50 was 24. But here what we did is, we considered that let us take up to moderately polluted as a good days. We defined it as these are the good days, and how many days these cities are there in, like when we say 25 days, 0 to 25 days, 66 cities were there which were either good, satisfactory or moderately polluted. That means the AQI was less than 200. Now, if you see only there are 2 cities, or I can say 4 cities, which has more than 100 days of good air quality. Although we have taken moderately polluted also, less than 200 QI. So this gave us a grave concern that we need to work on very micro level with sustainable approach. This is again a replication of 1 year data to what exactly it goes, and you will find the same trend. Now, based on all this, we introduced this National Clean Air Program in 2019 January. The idea is to address non-attainment cities. So when we say non-attainment cities, this is basically cities which has exceeded or has not conformed to National Ambient Air Quality Standard for 5 consecutive years, because there are other factors which also come into play, like acute meteorological condition in a particular area may take that city beyond acceptance norms. So we said that if for 5 years a city is showing a similar trend, there is a problem. Let us target those and let us prioritize those. It's not that other cities are not being taken in a comprehensive way. Here in these 124 cities, we are taking a very comprehensive approach, and we have a target-based action plan. So this is 124 cities across India we are working as of today, with a target that we will be achieving 20 to 30% reduction in particulate matter by 2024 on a base of 2017. And we found that there are various schemes and activities which are happening on ground. The only thing is how to synchronize those activities in such a manner that the objective of improving air quality can be achieved. How to prioritize them, how to make synergy between 2 activities so that the results are beneficial and meets our objective. So interdepartmental coordination and convergence of action was felt after gap analysis that was very much essential. Another thing, limitation, what we found was that everyone was aware about what problems are there with respect to air quality, but they still exist a huge knowledge gap among the implementing agencies. What to do, how to do, what are the things we need to do. So lump sum basis, macro level they were able to do, but they were not able to do it in a very scientific base because there lacks a gap on air pollution scientific data approaches. So to address this, what we did is we identified educational institute in their locality and made them partners to these urban cities, a dedicated partner to provide all knowledge base requirement. Knowledge resources provided by these institutes, because the implementing agencies are professional in project management. They are although they are sensitized on air pollution aspect, but that is not their domain expertise. So these technical institute or the institute who are working in this field, they provide the knowledge gap, they assist them in scientific studies, extend them, all help to execute those things. We took, I will don't like just to give you an indication. The second column gives the numbers. These numbers are indicative and dynamic in nature. But this slide I wanted to just stress upon is what are the major gradient we have taken as a thrust area. We have developed city action plan for almost, now it is complete for 122 cities. 2 cities still we are doing it because there were challenges. We took it up very late. When we say city action plan, those are macro level where the major activities has been identified, major stakeholders has been identified, resource, fund and financial things has been tied up, and broader targets has been given. Now, among that 42 million plus cities where the population is more, the stress is more, there we have gone further and we have made micro level action plan, which talks about in a particular year how much kilometer of pavement has to be surfaced, what is the area we need to put in green coverage, what will be the target of emission monitoring, like those things on quantifiable basis with a shorter time frame, with a dedicated team and stakeholders has been done in micro level. So we have a macro level where the smaller cities are working, and micro level to get into the because these cities, for million plus cities, are big in nature, and it's very difficult to have a generic because it is not effective. So micro level dedicated hotspot based area specific targets has been defined, and those are being implemented. Then how, unless we know the cause, we have to do source apportionment study. Many there has been a session, people have talked about it, I will not go into that, but what we do is source apportionment and emission inventory. We are developing a very robust emission inventory because once we know the causes, their contribution, the prioritization and the interventions, whether it is implementation, enforcement, regulation or policy, we will be classifying those things after inventorization, and then those things will be taken up on systematic way after due diligence and consultation with all the stakeholders, especially the implementing agencies. Source apportionment is a continuous process, and we are trying to build up a system where real-time system such studies can be taken up. These are in very initial stage, but we are hopeful that 1 or 2 pilot has been very successful. I think one lecture from IIT Kanpur, Dr. S.N. Tripathi has taken. He may have talked about it because we are working very closely with them. Similarly, emergency response, I have talked about it. What we say graded response system based on AQI of a city. Those has been developed and being implemented. Then we found that a dedicated cell at urban local bodies has to be there, so that people, any person who are in a particular area having air pollution because of some sources, open burning, some causes are there, so he can call to that cell and the response team can be sent to contain it as early as possible. So now almost 42 million plus cities are having and they are functional. Remaining 80 cities, we are almost covered 62 cities where these are functional, and we have tried to come out with IT enabled system where centralized complaint can be done through mobile app or through internet. You send your photograph, it will capture the GPS location, and then you write what exactly is the case, and then corresponding in this regulatory body or the responding agency will be intimated, and they have to go to the site, close it and upload it back, and then the upload, the whatever has been action taken has been done, that will be again communicated to the complainant. So these things are in place, things are working. There are certain hiccups at smaller cities, those are being addressed. Then we have brought in all these IOR to 122 cities. They have gone into memorandum of understanding, legal bonding, where what they will be doing, what will be their scope, what will be their financial and resource management practices. All things has been delineated. Similarly, monitoring stations as per adequacy. We were finding it very difficult that one station or two stations were there on which basis we were dividing the entire air quality of a city, which may not be representative because the stations may be operating at the stations installed may be on a different criteria or a different purpose. So what we did is we have framed a guideline based on population and geographical location and area. What should be the ideal or minimum requirement of monitoring station to have a representative air quality of that city? And we have derived that for industrial as well as urban area. And that urban area has to make sure that by this year end, when we say this year, because of COVID, we got delayed. There were issues of supply and everything. So we have extended that by 2022 March. All 122 cities will have minimum number of monitoring locations as per some sort of scientific study installed, what the guideline we have prepared. And then what will be the number of manual to especially look into sensitive areas which are more metal based like arsenic, nickel. So those things we do on manual monitoring. So sample monitoring of such parameters are also being taken up. Now, is the air quality management stages? What we feel is, first we have to identify and recognize the problem. We did it by monitoring and assessment of ambient air quality and the sources. We identified the sources, then we documented it. We did the gap analysis. We tried to get secondary information put in place. Based on that, we came out what are the roughly sources, who are the stakeholder with whom we need to take consultation, how to make them participatory. So all these things and make them realize that yes, air pollution is a cause of concern. Please recognize this and start making your contribution for community participation and everything. So stage one has been completed. We have come out and we got a lot of support from legal fraternity like our Honorable Supreme Court and Honorable National Green Tribunal. They had been very helpful and they have been pursuing. They have provided all necessary boost and support for taking this further. Similarly, then based on that, once we come out with that broader concept, what is the area-wise emission, then we try to do a real-term emission inventory. Now, when we see emission inventory, the idea here is to have a robust system which being a dynamic emission inventory, basically, if I take number of vehicles, now that goes on changing. And so the system of maintaining the inventory is mostly we are denominating on IT base. It has to be robust, dynamic. And then what are the interventions to identify the total contribution through source of apportionment study and other things? Which are the prime targets? And we do a trade-off like clean fuel. When we said it was a considered view that investing that much will be a good option from switching over to emission 4 E4 to Bharat Stage 6. The trade-off was very calculative, and then we found that it is cheaper to move to have a leapfrog, although the investment was huge, but then ultimate goal was achieved. So similar things has been done. Like another scheme what we have is Ujjwala, where now we are domestic wood-based fuel was there. We are trying to replace, and almost 25 crore, that is almost 250 million houses right now have this. So and all those things are being taken up. So there has been a lot of policy interventions in that area. So these all comes from the emission reduction at source, like what are the measures we can take. Many things are looked into that. Same reduction at pollution level, regional level and source base. These are the complete scientific one which needs to be done in parallel, and we are doing it. It's not that all cities have completed their source apportionment, but we expect by next year, June, all source apportionment studies will be carried out, and accordingly the action plan will be again remodified. And priority of action plan is on non-regrettable measures has to be get into place. And then reduction impact, we do, it's a common scientific methodology where do a trade-off, what policy interventions you do and what benefits you are deriving, and investment wise and the benefit wise analysis is done, and then action plans are prioritized. Now when we do about implementation strategy, what we took was, first we needed to have a monitoring and evaluation system in place, that whatever action plans are there, how better, how efficient those are in implementing, whether they are meeting the timelines, what are the bottlenecks they are filling, whether those things needs to be addressed. So we institutionalize a comprehensive authoritative committees which are monitoring and doing all enabling provisions at urban level, state level, provincial level, and at national level. And they do monthly meeting, quarterly meeting, and take necessary action to debottleneck any hiccups, provide resource, prioritize the thing, see why something is lacking, and those things are being monitored at that level. At execution level, even things which come at policy level, we work on it, and on annual basis we review that. Similarly, what are the financial support available for them? Now there is a huge financial support, almost I can tell you in last 2 years we have passed on to these ULBs something around 4,700 crores of rupees, which worked out to be 44, when we say that is 440 million rupees we have given to these urban local bodies, the urban cities, to work upon measures which will improve the air quality, especially the action plan which has priority. And those are being monitored by third party about the efficacy. And then these committees are reported upon. And there is a whole sort of a mechanism which looks into this for implementation and efficacy. Similarly, the strengthening of air quality monitoring stations, I talked about it. Micro level city action plan, we have completed for certain cities. Now, once we collect this data on investment activities and what are the corresponding improvements, these has to be collated and passed on to the public so that what we are doing, the achievements will come in a longer time. But whatever activities are being done, these are put in public platform. We have developed a dashboard which looks after centrally, and every city is specific what activities are there. Anyone can go and see that dashboard and see what are the activities planned, what is the progress, financial and physical, and when it is going to be completed. If not, if it is below the target, what are the reasons? And then the people are aware and they can put pressure at the local level. So it is just to have a participatory from the urban base. Then another approach which is more realistic and effective is hotspot identification in urban local bodies. It is not that every area is uniformly or having uniform problems. There are some pockets in an urban area which contributes significantly to the air quality. So if we identify those areas, the causes, the measures we need to contain those sources or reduce the sources, the half work is done. So we have identified, we have done many studies, many of the cities has come out with their hotspots, and they have started working on micro level hotspot specific monitoring mechanism and action plans, and those are being implemented. So we believe that if we address urban local body hotspots and we are able to achieve even 70% of the action plan, the city air quality pollutant load will reduce to significantly 30 to 40%. So that is a prime target what we are doing, and it is based on complete scientific study, grassroots level monitoring and inventorization. And then definitely, as I said, that IORs are being part, they have been asked to do scientific study, provide the scientific knowledge gap, address those things. Now, for participatory part, what we have done is we have brought in the educational institutes, the students, the community, to make community groups to take care of like air warriors. Those things has been done so that the local people at the colonies level, at the street level, they start sensitizing, they hold group meetings and take care of their locality, what are to be taken care of that. So those are long term, but then these things are now working on place, and people are, there are good response in this direction, especially on locality wise community development and their participation. Then to have a uniformity, the best practices and the best benefits derived out in benefit as in one city, if some city has done something and they have found that they have derived good benefit out of that. So we try to put up in a best practice model and in form of a guideline, circulate to all cities to explore, adapt those things in their city, their environment, and see whether it is feasible. If it is feasible, go ahead and do that. Similarly, state level policy interventions are required because every state has their own priority because of their development status. And those things we are trying to negotiate and govern so that there is a not much disparity between two neighboring states, so that one state cannot say that you go on polluting whereas the impact is going in next state. So those things are being taken up. New technology interventions, demonstrative project, we talked about it, third party evaluation to have an independent view on the efficacy of the system, and mass awareness, that is always there. And it is one of the major thrust area to have behavior change. Now, what I will do is most of the things are micro level. I will just go across it. I talked about source apportionment, emission inventory, city level action plan are there. Then sectoral base, what we have done, I will just go across and read out because these are indicative and this will give you some idea per se on this. Because a specific city, every city will have its unique challenges. Something may be common, something may be unique, something may not apply to one city or the other. But what we have done is these are generic, and when we look at it, more or less every city will have these major problems. So challenges basically to address. So I will just go through, run across so that my indicative idea perspective is there. Like when we talk about industrial pollution, industrial emission, we are talking about primarily gradual shift from traditional coal-based fuel to compressed natural gas, PNG, and in this direction we are building infrastructure. We have a timeline. We are prioritizing the industrial sector areas to push these clean fuel faster. We have a timeline, and we are discouraging petcoke per se. And we have almost many of the cities has banned use of petcoke, which contributes sulfur and particulate matter. Similarly, the power, I am happy to tell you all that in India now we have improved on power supply. Almost many of the cities are 24/7. Many of the rural areas get more than 20 hour of power. Some areas are having 24/7. So now the DJ sets are only required for emergency purposes. And we completely ban DG set where the moment we attain bad or poor air quality index. Only for emergency we allow them. Similarly, for power plants which has a longer influence impact zone, what we have done is we have come out with more stringent norms. 150 was there, now we have come down to 50 particulate matter. There we have given them time and we are working on it. Similarly, region specific airshed based localized stringent norms model has been worked out and those are being placed. We encourage emission trading scheme within a airshed so that the techno-feasible and financial aspect all works together. Investment are there in cleaner technology and people who are doing better can derive out of that. So that model, one or two places, it is working very good. Similarly, brick kiln has been a challenge. And now almost pan-India, we have more than 80% brick kilns switched over from bull trains to zigzag. And we hope that some interiors may be working, but more or less by this year end, all will be switched over to zigzag technology. The benefits are obviously known. As far as vehicular pollution is concerned, emissions are concerned, metro rails, public transport, CNG and electric buses. Electric bus we have been able to work out. It's yet to be commercial way working, but then that is in our agenda. Similarly, promotion of electrical vehicles, BS standard 6 standard vehicles pan India. Last year onwards, no vehicle is sold in India which is less than BS 6. Similarly, LCV to switch over to CNG and then automatic PUC, pollution under control certification system, which is now computer driven. You get a SMS when your car is due and you will get on getting those SMS till you get it certified. So those things has been taken up. Similarly, for household, we have gone for LNG. We are now working on ethanol cooking fuel, how to work on it, how to provide that. Similarly, open burning at locality, community level, we are trying to put in people groups, ensure that these burnings does not take place, and then to promote circular economy as a side benefit, segregation and collection of solid waste from household. There are almost 100 cities which have achieved 80 plus coverage, 80% plus coverage of segregation and collection. Disposal and recovery process we are thrusting upon. We are hopeful by next 2-3 years we will be having better improvement in this. Resource recovery like CND waste and everything. Infrastructures are under development or at planning stage. We hope that within 1.5 years these will be functional and most of the construction and demolition waste or recycling mechanism, organic farming, even the old municipal solid dump sites, what we call it legacy waste, will be disposed of within next 3-4 years. That is our target. I talked about this. We can skip all those things. Now, one is stubble burning, which is a major cause of concern. There also we have working with the farmers. We are providing a lot of incentive, trying to have alternate use of this agro residue in form of biopellets, bales as raw material to industry, as co-firing, co-fuel to power plants. We are trying to give incentives, even as a fodder, we are trying to lift it from across 100 kilometer to 200 to 500 kilometer. So these are being worked out just to ensure that the agri waste is a resource which should not be burnt, rather it should be used and seen that it will reduce the carbon load, greenhouse gas aspect also. So multiple dimensions are there for this to promote. We are having in 200 urban areas the vacant lands promoting Nagar 1 scheme It is basically a scheme which promotes forestry, green coverage increase within the city area. Our knowledge partner we have worked about, we are working with the international agencies, many of the almost 12 countries and World Bank, UNDP, UNEP, all have shown interest to be partnered with this program. They have taken up some pilot studies. They have partnered with some cities. They are working on some new ideas, adaptive ideas, and that way we are looking at it. So these things are there on that. Just a minute. Similarly, what are the other challenges we will be just discussing? See, when we do a study, we found that there are other peripheral challenges which needs to be looked into for effective implementation with higher efficacy. The participation will be good, the objective, and there will be less bottlenecks. Hindrance will be less. Because once you roll out the action plan and you want to implement it, there are a lot of things which crop up at macro level. And that is because those stakeholders were not taken into consideration, their views were not looked into. So first we look at it. And other aspect what learning is, there are many pollutants which are interdependent. So addressing one pollutant will not yield the desired result. So later on we found that, okay, that also has to be looked into. Like if we don't look at sulfur dioxide emission, sometime we have to find that the PM2 point is very difficult to address. So the cause has, there is a huge significant contribution of sulfur dioxide to PM 2.5. So there has to be some action plan to contain sulfur dioxide. Why I'm saying this? Because the sulfur dioxide has never been a concern per se as a air quality pollutant parameter per se in any of the area. Out of 1000 monitoring locations what we have only 10 or 12 stations where the standard is exceeded in some of the days. Rest of the place we don't have sulfur dioxide is a concern parameter, but they contribute somewhere to PM 2.5. So that is one of the major policy interventions we took, that all our power plant, something around 1.25 lakh megawatt or 1.25 gigawatt power plant, have been asked to complete FGD, what we say, flue gas desulfurization unit. They have to put up by next year, which will be amounting to something like 75,000 crore investment. And this is only to do with contained sulfur dioxide, which may not be a concern as in form of sulfur dioxide in ambient air, but it contributes to particulate matter, and PM 2.5 is a concern. It will be addressed together. This is a classic example I am giving. Similar, there are many other things at local level also. Local authorities has to be put in place. Without their help, you cannot implement it. There has to be a coherent approach. We have to negotiate with the stakeholder. We have to understand others' position, their constraint, and bring out what is the best possible thing where we both agree. It may be a very small step, but that way we have to go. We have to keep in mind that we should not have any time like we have found that better has been always enemy of good. So our approach is, let us go for good, don't target better. Better will come over a period of time. So let us start with good. So that is our approach. Similarly, reduce the source of pollutants, qualitative and quantitative. That is another thrust area, like changing over of fuel, shifting of industries to an area where assimilating capacity is good. So those things are there we need to. And the most important is the risk appetite of the society to take the economical burden arising out of that. Employment, economy, per capita income, how it is going to impact, what are the, because livelihood impact, lot of things has to be looked into, and based on that we have to provide enabling provisions, alternate, and then we work on those critical area. However critical it is, but then unless and until we provide alternative source, we don't target that. So those things are there which we look into, take into consideration. And the most one is to bring in participatory part where the investment comes from the industry and they don't feel alienated because industries are more soft target, whereas the major source comes from individual household and individual contributions. So those factors, less energy consumption, because more the energy intensive a city is, more pollution will be there. Again, it depends upon what is the matrix of energy basket. Whether if it is on non-renewable source, we don't have any problem. But if it is on fossil fuel basis, so we have to understand that are we shifting the problem from one geographical area to another area, which will come back to my zone through transboundary movement. So these things are also to be considered. Now, I will be open to the discussion. I thank you all for having a patient listening, and I will be happy to have any query on this. Thank you.
Thank you, Mr. Sandeep, for your nice presentation on the National Clean Air Program of India and what India is doing in for controlling the pollution, air pollution. So it's very nice presentation with very new informations, and I hope many countries will take this as an example, and they can try to implement some component of this program to their country. So may I request the participants to write your questions on chat box or Q&A box, and we already behind the time, but it's okay. We can take few questions from you. Please write your questions on the chat box so that Mr. Sandeep can ask can respond you. Oh, okay, there is a question. Does India also have waste to energy plants to handle solid waste product produced by different cities? You are muted, Mr. Sandeep.
Now it is okay?
Yeah, no, it's okay.
Yeah. This is a very good question. Like this is a catch 22 question, whether we need to have waste to energy plant or not. Number one, we do have waste to energy plant. Location is definitely a challenging issue. What happens when you put up a waste to energy plant, basically to generate power or some energy basically. When you put up these plants, what happens? Those plants are out of our urban area. In last 10 years, the way we and India have grown, especially in urban agglomeration, has gone up. 2020 and 2000, if we see in last 20 years, the city has grown exponentially. It is beyond the average growth and even in geographical. So the concern has been there, but most of the cities has gone with the precautionary preventive pollution control equipment installed with this. There is a concern of certain dioxin furon. Those things through appropriate pollution control equipment has been addressed. Now, every waste to energy plants which are planned, I think there may be not less than 20 across India, which is operating, generating up to 30 to 40 megawatt per unit. Even to the extent there are many in pipeline, but all these plants are mandatorily connected with real-time monitoring system, and those are being very closely monitored, not only by the local community, by the pollution control boards, but online through a system which is in public domain. So these are there, and the best part is you derive municipal solid waste Now, when we talk about legacy municipal dump sites management, waste to energy is one of the options to deal with that. And some of the cities has gone for this because this provides less space compared to other method of doing managing those things. So yes, it is there, and many of the cities are there which have adopted this method.
Okay. How successful were the ideas of using a smoke gun and a smoke town in improving the ambient air conditions, especially metro cities, India, as the idea seems very low novel from the perspective of developing countries?
Yeah, uh, there are two items in this. One is a smoke gun, another is a smoke tower. Now, when we talk about a smoke gun, basically it is nothing but a dust suppression mechanism. It's very effective at construction sites because when we have a construction site, there are a lot of localized fugitive emissions. So if I have a canopy of a mist developed by this gun, fog guns, it helps. Similarly, it also helps when we have a very acute meteorological conditions to get certain scrubbing mechanism in place. So increase the moisture content, and then there is a scrubbing happening at a level where you need to do up to 3 meter, 4 meter. If you push your gun and increase the mist in that, there is a natural scrubbing happening. So the particulate matters get settled down. Although since it is a static meteorological conditions, there is no wind movement, so you get relief for certain period. As far as smoke guns are concerned, these are very effective at construction site, pavement, and parks, those where it has shown very good results. Whereas when we talk about uh, especially in smoke tower concept, we have recently come out with two smoke towers. These are basically nothing but a cleaning mechanism installed for ambient environment. Uh, we are taking it under a pilot scale with more sort of a R&D approach, and we are looking into what benefits and outcomes we can derive out of that, and see what basically we are looking into the quality benefits arising out of it. It's a scientific research work. Two such towers has been installed in one at Delhi, at both in Delhi metro area, and these are yet to start. On scientific protocols are to be made. We hope that by next week we will be starting its operation. We'll be doing a lot of scientific study to derive what are the benefits coming out and see whether it can be replicated or not. The cost is huge. It is designed top to bottom approach where we suck it from the top about 30-meter height, and then clean air after passing through multiple filters which capture larger particle as well as PM 2.5, release it at 3 meter and below level, so that the ground and the impact zone is almost 500-meter radius. So these are the design parameters we are working, but we have to see what are the other benefits we can derive out of that.
There are several questions are coming up. So one of the question is, what challenges do you anticipate on meeting the micro scale clean air plan for urban neighborhoods?
It is, there are very, it's a very challenging thing. When you macro level is based on broader concept. You define in macro level that, okay, the roads has to be paved, you have to have a cleaning of roadsides, then you have to have a pollution under control, emission inventory, vehicular checking, you can have switching over to PNG. But when we do a micro level assessment, you have to get into the implementation stage. You have to go activity by activity. What are the various activity which will achieve one of your action plan? Now, when you do the micro level activity identification, then you see there are not the government agency which are the stakeholder. There are private agencies also. Like many a place you find that only 500 meter is left over because that is a private property and you have not got access, and because of that the huge infrastructure developed is not working because you cannot pass the electric pipeline or something shortcut. Similarly, when you talk about, there are challenges like one institution was informed later and by that time their fund were over, so now they will have fund in next financial year, so entire thing goes haywire. So those challenges, what we did is through NCAP we have a small kitty and we address those critical part if to a certain extent to meet the objective on priority. So we have not only the funds come from the respective department. Under NCAP, we have certain amount of fund which we use it to bridge those gaps to achieve the objective or micro level plans.
Yeah, there are several questions. So I just picking some questions which are relevant to the government agencies. So there's a question: what does the government employ to reduce the tailpipe emissions of diesel vehicle?
Diesel vehicle, we are working on two model, especially vehicle. What we found that 2 to 5 ton carriage weight diesel vehicle, and we are in a very advanced stage that we will be able to put some retrofitting in those vehicles which have a life. Just to highlight one aspect of recent policy change, we have come out with a salvage policy where now we are defining that all vehicles, diesel vehicle will have a life of 10 years. So although we are working on retrofitting of some equipment for containment of tailpipe emission, and by next year we will be coming out, that will be only useful for those vehicles which have leftover 5 or maximum 5 to 6 years, then it makes sense to get it converted. If it is less than 5 years, there is no sense in getting it converted. And we are working for it, and we are almost through for two types of vehicle, and we are looking into, even for DG sets we are looking how to retrofit the pollution control tailpipe mechanism to have better emission. Those are in place.
Okay, one more question of, let's say, basically from the same participants. Okay, what strategy do you consider for controlling the transboundary of air pollution? And also it's linked to the same questions. How do you regulate the open burning practices? So it's basically both questions are similar.
Although both are the same cause, but I will deal it separately. As far as transboundary concern is there, with the help of World Bank in Indo-Gangetic Plain area, we have worked out and we found that 20 to 30% of the air pollutant load is coming from outside the city boundary, even of the state boundary. It may go up to 30 to 40% depending upon who your neighbor is, what type of activities are there, and which pollutants we are talking about, what is the meteorological condition, what is the geographical conditions. Like emission from a power plant can travel up to 1000 kilometer, 800 kilometer, 600 kilometer, even 100 kilometer. So it all depends upon which geographical location, topography, and the climatic conditions you are operating. Now, having said that, this needs to be looked into. So there needs to be a policy intervention to eliminate the cause or to contain the cause. And that is the reason we realized it that power plant are the major contributor for transboundary, and that we have taken very stringent norms for them. Similar norms we are trying to get into similar height, similar load based sources. Maybe it is power steel plant or cement plant. We have come down for cement plant up to less than 30 milligram emission, which was 500 and 100, 50 and 100. So we are reducing those things which has the potential of transboundary. That is the only way out, because you cannot do anything on meteorological and climatic condition. Even you want to change meteorological and climatic condition, these are very long term, 20, 30 years to deal with the land use pattern. That will have some amount of changes, but these are uh, much more beyond our scope. So we tried to contain the source to reduce the transboundary contribution. Now the second point was open burning.
Yeah.
Open burning and stubble burning or crop residue burning, we treat them all as it is. There are two types, if we may say so. The smaller open burning of municipal solid waste in community, they have an impact in the range of 3 to 4 kilometer, 5 kilometer. Whereas when we do a crop burning in an area of hectares and acres, it becomes not a small source, it is a major source which can travel up to 150 kilometer, depending upon the heat it generates, the temperature it has, and what is the local meteorological condition to lift those pollutants to a level when it goes and get into transboundary movement zone. So these two has to be dealt. And again, the idea is for larger sources, we try to contain it at source with the help of multi-stakeholder, irrespective of the administrative boundary. And for local, we have derived community participation and the municipal bodies to lift the waste as early as possible. The collection efficiency has to go. Door-to-door collection has been, many of the cities has now come down to door-to-door collection. So community dump sites are very less, and those are being taken care by municipality. These are the two approaches we do.
A few questions from Pakistan because participants mentioned the country. The first question from Pakistan is, what are some of the challenges that India's environmental regulatory body face in implementation of environmental law, especially considering that municipal or local bodies are the implementing partners?
Definitely, when you deal with local organization, I can understand what concern may they also be facing. When you deal with government to government and government to a private, general perception is that people are very lenient on government to government, and that is the reason things does not percolate or move faster in government sector. The question is basically, when you are dealing with urban local bodies, you are dealing with a government agency, what are the challenges you are facing? Let me give you a good idea. There we have got a very good support, and initially there were certain hiccups, but now things are, my urban local bodies are more proactive than regulated, I can say so, because the legal support we got from our honorable NGT or Supreme Court has made them submit a time-bound action plan, and those progress reports are being submitted and they are held responsible if they may fail, and there is a provision put up as per the order. The regulators are now empowered to put up environmental compensation if they don't abide by that, and those compensations are put in place in crores, and the response every activities, the responsible officers are been identified. So the nodal officers are there. The chief secretary is responsible for getting those things implemented as heading the chairman of the committee. So the things are moving fast. Earlier we had such challenges, but now we are very smooth and we are working very coherently and equitably, I can say so.
Okay, linked to this question also the same question from Pakistan. How strong is the support mechanism for environmental regulation in India? That is the annual environmental budget, human resources allocation, etc.
I will put it separately. There are two methods. What we have approached, we have provincial state pollution control board, who are the regulatory bodies entrusted to regulate, monitor and enforce at provisional level. Then we have a central level where Central Pollution Control Board is there, which provide knowledge base and other peripheral support, exchange of ideas from one state to another. The Central Pollution Control Board, the national authority, works as a big brother to all these, and that way it moves. As far as resources concerned, the major challenge we have is of human resource. All regulatory body, it is a fact, there are many things which is in open, and we all know that human resource is a major challenge. As far as financial resource is concerned, there I can categorize it into two parts. One is we have state pollution control boards who are rich enough to even make most of the things. So they do not have any problem as far as financial resources is concerned. But because of some technical issues, they are not able to put in so many human resource in place. There are another group which are very weak financially because they do not have much industrialization. There is very less revenue source, and the state governments also are not that developed to support them, especially our friends from northeast and some smaller states which are not much industrialized. For them, from central government KT, we provide them all assistance to do the minimum ambient monitoring mechanism and their support for functioning. So these are the two methods what is being worked out.
There is very specific question about the continuous ambient air quality monitoring system. They're asking how many stations do you have in New Delhi?
We have almost 14.
Okay, 14. Okay.
14 is from, just let me put you, when we say 14 or 200 or 1000 we have operating, these are from under government finance. The data and the instruments are funded by either state, provincial, or the national government. Apart from that, we have identified 17 types of 17 category of industries which are highly polluting in nature, and they are all expected to have 3 minimum continuous monitoring stations operational, and those data are also being populated on our website. So if you ask me, the total number will be something around more than 2500 across India. But from in government sector, we are running on something around 350. And in Delhi, we have 14 or 15 right now.
Okay. Thank you, Mr. Sandeep, for your nice presentation and discussion after the presentation. It's very nice to hear you the example of the clean air program in India. So thank you so much for your time and for your efforts and to contribution to the workshop. Now it's
thank you, Dr. Verma. With your permission, can I leave?
Yeah, sure. Thank you so much.
Thank you.
Now we have come to the end of the presentation on the air pollution mitigation policies module. In fact, it was the last session of the workshop. It was a long session of the workshop for more than 5 hours, and I know you all must be tired. So, however, please allow me to say a few words as a closing remarks on behalf of the Secretariat of this workshop. Distinguished participants, expert speakers, colleagues from our partner organizations, ladies and gentlemen, good evening or good afternoon across the different time zones from where you're joining this workshop. Participants, thank you so much for joining the workshop for 5 days. We have immensely satisfied with the feeling to have you in the workshop. We had almost more than 300 plus registration, and then 200 plus attendance on the first day, and then after around 150 to 130 to 150 attendance for every day, rest of the 4 days. This is indeed a incredible it is not easy for you to remain consistent in attending the workshop for 5 days continuously and listening the presentations for 4 to 5 hours every day. So thank you so much for your continuity attending the workshop and for your interest. This means a lot for us as an organizer. In order to provide you the holistic knowledge on air quality management, starting from monitoring to emission inventory, to modeling, to impact assessment, to mitigation policies, we have invited globally renowned experts as speakers, as you might have noticed. They shared a wealth of knowledge and experience on air quality management. We hope you learn a lot during the workshop, which will be useful in your work and studies. We have uploaded last 4 days PPTs and videos on the website. Please read them and watch the videos when you have time. Please provide your feedback on the evaluation. A Google form is attached in the evaluation section of the website. Please visit there and fill the evaluation form. Evaluation feedback is important for you as well as for us. For you is to get the certificate, and for us to get the feedback on our organizing the workshop. The last date of the receiving the feedback is 27 September, that is 10 days from now. After, we will process your certificate, soft copy, and send to you by email. We would like to extend our sincere gratitude and appreciation to all the speakers for devoting your valuable time for the workshop and shared wealthy knowledge and experience with participants. Your contribution to workshop is simply outstanding. So thank you so much for your great contribution to the workshop. We would like to express our sincere gratitude and thanks to our partners, partner organizations, namely colleagues from AIT, and then colleagues from Pollution Control Department, PCD Thailand, colleagues from Environmental Research and Training Center, ERTC, the Ministry of Natural Resources and Environment, Thailand, colleagues from National Institute of Technology, ITENAS, Indonesia, and then colleagues from the University of Malaya, Malaysia, and the colleagues from the UNEP Regional Office for Asia and the Pacific. And the last but not the least, colleague from the Asia Pacific Network for Global Change Research, APN, for their support. Your contribution to organizing the workshop is incredible. Without your support and cooperation, organizing this workshop would not have been possible. I would like to express my sincere gratitude to Director of RRC.AP, Dr. Naoya Tsukamoto, for support and guidance for you provided for this workshop and this project. And last but not the least, I would like to express my sincere thanks to my colleague Bayasa and my colleague Senja and Miss Pinky for providing RT support, for developing website and updating the website regularly, and for providing the necessary secretary support. So thank you so much, Bayasa, Pinky, and Senja. Without your support, we cannot imagine to organize the workshop online. But this is not the end. The workshop, this is not the end of the workshop. We have something for you participants. Although this was not in the agenda of the workshop, but I'm adding here a new agenda. That is chit chat. Let's have a online chit chat party something. Since last 5 days, you were forcefully muting your microphone, switching off your videos, and not allowing you to speak. Not allowing to switch your video. So, but now we are unmuting you, opening your video options. Now you are allowed to speak and express your feelings, even if you are unsatisfied with the workshop. as you are listening me for 5 days, so you can also complain about me. If I would like to express your feelings on workshop, just say it now. May I request my colleague Bayasa to allow you to unmute and switch on your video. So please open your video and raise your hands, and we will allow you to speak. Thank you so much. So if you want to say something, just raise hand and say. Can you allow everyone? Okay. We have unmuted you.
So can I just go first?
Yeah, sure.
I'm Sadia Over. I'm working with Pakistan Environmental Protection Agency, which is the regulatory body in Pakistan. I think it's really unfair. You've given the rest of the speakers 5 days to speak, whereas we're giving a few minutes. This is a very good workshop overall. We learned it. And the only thing that I truly missed was networking with the participants, because from the comments, I could tell that there are so many learned members of the air pollution control community who are working and who are participating in this workshop. So thank you, EIT, thank you to you for organizing this, and to all the speakers for giving us time so that we could learn new things in our field. Thanks so much.
Thank you. Anyone more want to speak? Maybe colleagues from PCD, Dr. Itipol. Can you please unmute? We cannot hear you. Mr. Kamales T. Please unmute yourself. Please unmute when you speak. We cannot hear you. Please unmute your. We cannot hear you. Please, those who are speaking, please unmute yourself.
Hello, am I audible?
Yeah, sure. Mr. Arvind from CPCB Vadodara.
Yeah. Thank you, sir. Thank you for providing the opportunity to all of us to learn various new things. All the presenters were very nice, and definitely Secretariat has taken a very good initiative, especially for the people like us, so that we can have a comprehensive knowledge from the citing of ambient air quality to managing the ambient air quality. It was a very nice presentation. Your IT team efforts are super, because we did not find any technical glitch in your in your IT communication. Whatever glitch were there, definitely that were in our end or the presenter's end. But at your end, it was very nice. We are thankful to AIT, we are thankful to RRC, and definitely to you and your team. Thank you so much.
Thank you, Dr. Arvind Jha, for your comments. Anyone else want to speak? Please unmute yourself before speaking. Seems no comments from participants.